You just fucking made one, dude.
Yeah, you did.
I
You
just
said everything you say is pseudoscience, bro. Come on,
right?
bro.
Because you guys don't have any evidence to back up what you say. So by your definition, you're
Yeah, you haven't defined the term. You supposedly gave examples, but you beg the question as to what is pseudoscience.
Again, I did not ask a question.
For half an hour, Greg.
You didn't answer one.
You can't beg the question.
Don't need
Don't
anybody else. So, is an aspect of a surface a claim for science? Would we be using the scientific method to figure out an aspect of a surface? Is an aspect of a surface a cause and effect relationship?
Well, wait, what? What kind of gotcha question is that?
Trying to ask you if you
The
understand
aspect
what
of a
science
surface is there? I mean, does the surface of the shape of a surface cause the aspect of it? Like, what's the cause of a shape?
All right. Yeah. Let's try and ask this.
That's the question you're asking. What causes
in geometry to figure out the shape of an object? Are we going to be using natural science to figure out the shape of an object? Come on.
Okay. What do you mean? What do you mean? Come on. You fucking go measure it.
Yes or no?
What's a yes or no? How is that a yes or no question? Are you just
a yes or no question?
Do
you hear that, folks? Doesn't know what a yes or no question is.
Well, it depends on what the loaded question is.
Figure out, shush, especially listen now. Third time I'm trying to get this through to you. If we're trying to figure out the shape of an object, are we going to be using natural science?
If the object is natural, yes.
God. You understand that natural science elucidates cause and effect relationships demonstrated through experimentation. Would we use this method to figure out the shape of an object?
Yeah, like what causes the shape of a tree, Jedi?
We're not asking what caused the shape. We're asking what the shape is.
Okay.
A what is question isn't a question for science. Science deals with how and why things happen. So you're trying to make
that's your narrow understanding of it. That's untrue.
You're trying to make
I don't agree with that.
Straw man by saying that we don't have any science for our claims, and our claim at the moment is a what is question.
Right. What is the shape of the
Earth? Not a question for science, dumb fuck.
Oh, well, that's your opinion. You're wrong about that.
No, science deals with cause and effect. Follows the scientific
that's not what that means.
method.
That's not what science
does. Yes, it is. Natural
that's
science.
Okay, that's right. We're just going in circles with this, right? That's the problem. We're equivocating the word science.
I disagree.
Hey, Talon, I got a question. When you're dealing with science, you want to control for your variables, right? That way you don't have a false cause.
Right.
You don't want to conflate, correlation with causation, right?
Yep.
Okay, so you do understand how science works. Thanks.
Okay, right. And I know how science works, which is why I know astrophysics has science involved in it.
Science involved.
You guys
define science, Talon.
It's like it's a dumb argument. Like, why are you guys arguing about whether or not?
Okay, here we go. Define silence so we can move forward.
To what end are you trying to make this argument?
You're the one that brought it up that said that we don't have any science to back our claims for the shape of
objects.
Right,
you don't have any fucking science to back up your claims,
Dude,
Jedi. Give me an experiment.
My God, bro.
It's not
define science, Talon.
You're not making a claim for anything. There's no category that proves anything you say.
We're making a claim to geometry. Okay. The aspect of the surface of the Earth. Unfortunately, this particular piece of inquiry isn't what you would use science for.
No, that's your problem. I don't care about that.
How many times are we going to go in the circle?
It's not my problem. That's your problem, Jedi. If you think it's not science, too fucking bad. I don't care.
Geometry isn't science, bro.
You're the one who's setting
this.
This is an arbitrary. You're just setting an arbitrary standard that's saying astrophysics isn't science.
Okay, Talon, I got to put you on mute for a second, because if you don't understand that geometry is math and math isn't science, there's a huge problem. We're not going to be able to have any further conversations. You have to be able to understand this simple concept. Yes, sometimes scientists use mathematics as a tool to describe things. They also use beakers. So I'm going to ask you a simple question. Talon, is beakers science? Oh, I got him muted. Hang on just a second.
Are beakers science? I mean, beakers are measuring.
Are beakers science?
They're a scientific
tool. That's a dumb fucking question.
Right,
but
they're
if you
a
want
tool.
me to be like reductive, yes, Larry, beakers are science.
Beakers are science, really?
Yes, Larry, beakers science. science is
Are you
beakers.
serious?
Is this how you pull the web?
I mean,
See,
this
we
is like
can't-
what we're
we
reduced
can't
to.
talk to
Like,
the
you
guy.
guys,
We can't talk to the guy because
Are we
beakers are
serious?
not science, and geometry is not science. Go ahead.
Geometry is math is kind of ubiquitous with science. I mean, they're kind of
It's kind of the same thing. I ain't gonna lie.
No, Larry's already explained this. Science elucidates cause and effect, and you can use mathematics to describe, but maths and science are not the same thing.
Okay.
So when we're trying to figure out the shape of an object, in this case the Earth, we're not going to be using science for that. Science deals with cause and effect, how and why things happen. But the shape of an object is a what is question. A shape is a question for geometry and maths, not science. So when people like Talon turn around to us and say, you don't have any science to back up your claims, he's in a fucking category error. We're trying to figure out the shape of an object. It's not a question for science.
Talon, please read what I posted so that you can understand that math is not science.
So again, as we keep having this dispute with someone like Talon, the issue is that when that happens, the two or more interlocutors are either defining a term and then the other person is using the same term in another sense and therefore are equivocating. And so to eliminate the equivocation, they either need to operate with one of the other senses that they are saying respectively, or compromise on a third option. So to avoid this, usually in an ideal world, is to consistently either acknowledge the polysemous word that is science, because it is polysemous. It doesn't only have one sense. Or another logical argument. So another approach, another approach besides his disruptions, right? Another approach is to concede to one of the other supposed initial definitions, or to compromise on a third one, right? But to keep saying that this is not science because I'm saying science in sense A, or this is not science because I'm saying this in sense B, that's just an inane equivocation circle.
Is the Earth geometry, or is the Earth natural?
The shape of the Earth is a geometric question. So that's math.
Is geometry the Earth?
Bro, listen to what I'm saying. You are the one who said beakers is science, right? So listen to what I'm saying.
You guys asked that stupid ass question.
You asked the question, Larry. Why did you ask beakers or science? Just saying.
Because
if you say
apparently
no,
you don't know. Because apparently you don't know that just because a scientist uses a tool doesn't make that tool science.
No, you're trying to fucking. That's so stupid.
So this is just another inane circle, right? This is an instance of Talon being obnoxiously adversarial.
Like, are you pretending to be fucking stupid, or are you just like acting stupid?
Larry was asking a scrutinizing question.
Excuse me, may I ask something? If it's all right.
Yeah.
Yes,
so
Crystal, go ahead.
I am listening to everyone's sides. I just want to ask, so like, basically, we see the other planets, there's some we can see from the Earth, right? The sun is round. The planets that we can see are round. The moon is round. So, what makes you think the Earth is flat? What
You're
makes
gonna say the Earth
different?
isn't a planet.
Hold on, I'll answer it.
Just stop.
No, but what makes the Earth different? I'm confused. What makes it
It's fine. I'll answer it. It's because the Earth measures to be flat. It doesn't measure.
Exactly, bro.
Oh my god! It doesn't measure to have any movement.
I'm with this guy. Can y'all look at my screen share? Can like everybody look at my screen share, bro?
Hold on,
right. Do you want to get kicked out? Dude, next person interrupts me is just going to get fucking
sorry, my apologies.
Thank you. Appreciate that. Somebody's asked an intelligent question, so she deserves an answer. The answer is the reason why the Earth is different is because there's no measurable curvature and there's no measurable movement. That's why the Earth is different. Yeah, we can stand on the Earth and point at the things in the sky and say, hey, look, those are spheres and they round. I wonder if the Earth is a sphere also and also moves, but through direct measurement, we understand the Earth is not curving and does not move.
Well, if the Earth doesn't curve, then by that logic, wouldn't we just fall into space by the time we reach the edge of it? If you think it's flat.
So we would understand that the Earth doesn't exist in the vacuum of space like you've been told. So there would be no vacuum of space for us to fall off into when we reach the supposed edge of the Earth, whatever that is.
Wait, so are you just saying that we are on this flat circle and there is nothing beyond here? No?
No. Didn't say anything about a flat circle. Don't know where you got the idea of the shape
See,
of a circle.
Noah's posting something. He's sharing a video of a model that none of us are claiming. So if you're thinking what Noah is showing,
Well, no, I was
No,
trying to
no,
say,
I'm
like,
not.
how
I
did they
wasn't
take this
looking.
picture if it's not real?
bro,
Like, how you gonna say
can
that?
you please
You
end
clearly
the
see it in
stream?
there.
Can you please end that stream because you're straw manning the fuck out of us right now?
Is that
Wait,
not
what does
what
that
you
mean?
guys believe?
No.
No.
This is what I believe.
We-
Can I not like
we-
show
we're
my
not-
opinions and my beliefs?
That's
Yeah,
like
no,
one of the
we-
more
we
common
don't believe
depictions
that,
of a
dude.
flat Earth, isn't it?
May I
No,
ask
that is a
what
straw man.
may
No,
I
you
ask
just
what you
said-
think makes a planet and what you think the Earth actually looks like from like an outsider perspective then?
I've never had an outside perspective of the Earth.
So if I'm gonna ask this, right? So if we've had several proof of the fact that people have landed on the moon, we've had pictures taken from space, they've seen stuff, they've had the outside perspective, they know more than we do. Why do you think that, like, I guess because again, you just said it yourself, you don't have the information, you don't have the outside perspective, but they do, and they can back it up
They
because the pictures they've shown is stuff we can see from here.
Okay, can you give me a picture? Anyone? Are you
Yeah,
talking
sure.
about one that's been taken from the moon, for example?
Of course. Give me 1 second.
Okay, that's okay. I don't need the picture. I know the one that you're talking about. The very idea that people have gone to the moon is a bit of a problem in itself. Would you like me to explain why?
Of course.
Okay. Do you understand that the necessary antecedent for gas pressure is a container? Yes? To have pressure, you must have a container, correct?
Of course.
Excellent. We understand that the Earth is an open system according to the heliocentric paradigm, which leaves us with two problems. One, no physical boundary for the gas to press against to cause pressure. And two, because the Earth is an open system, entropy will increase and the gas will disperse into the ever-expanding volume of space. So we wouldn't be breathing right now if the vacuum of space existed.
Well, then there's where the atmosphere comes in, is it not?
That's gas. Atmo means gas. So
I have
the
a question.
So the
sorry.
oxygen and the nitrogen, that's the gas. Oxygen and nitrogen doesn't contain itself. It doesn't give itself pressure. For gases like oxygen and nitrogen, they need to press against a physical boundary to achieve pressure. So the atmosphere isn't containing itself.
So, so I just want to know, there's these astronauts, these scientists, they've gone to school for years. They are very smart. They have studied. They have gotten their diplomas, their bachelor's degrees, all of that.
Mm-hmm.
And I'm not trying to sound degrading when I ask this. Do you have any of that? This is not meant to sound degrading. it's like a genuine question because I'm going somewhere with it. Do you have so what do you have?
So I understand the second law of thermodynamics. I understand all of the gas laws, Gay-Lussac's laws, Boyle's laws, Avogadro's laws, all of the laws that make up PV equals MRT.
Where did you go to college and study a major in this?
Yeah. No, I didn't have to study a major. I have an A-level.
So that's a no.
Wait, so you're saying you're an autodidact?
Hold on.
All the disruptions down. See,
You know what an A-level is. So yes, I have an A-level in physics. Anybody can get these things. It's a very basic understanding of gas behavior.
There's a difference.
My friend, I'm trying to entertain you. So, do you understand what gas pressure is?
I do. I learned this back in 8th grade.
Did you have to go to university and gain a bachelor's degree to understand what gas pressure is?
No. However,
okay,
right?
Good. So we're on the same
That's not the
page.
question.
Then.
That's not what my question.
So we're on the same page then. You're talking about the vacuum of space and people having gone to the vacuum of space, turn around and take a picture of the Earth. But the vacuum of space can't exist if we understand fundamental laws of nature, like the second law of thermodynamics, like Gay-Lussac's law, Avogadro's law, Boyle's law. You understand what
What do you mean there's a vacuum in space?
I just wanted to say one thing as like my thought process, like a comparison, right?
No
There's
problem.
so we can easily look up this information on the internet and have like the same information that some scientists do, right? But there's a difference between having that firsthand experience of studying it and having it presented to you rather than just looking at it through a screen. Like I'm gonna use this is gonna sound really weird, but just like follow me here. Like mental disorders as an example, right? Some people can just take a quick survey and think, wow, I have it. But when actual evaluations, you're there for hours, you're studying, they take you through question, right? There's a difference between just having that information and actually studying it and actually going. A what?
Do you know what laws of nature are?
I do. And I also was in the middle of talking for someone that talks about getting banned for being cut off. You do seem to cut off a lot of people in here.
That's awesome, but you're going off track.
I was making a comparison to help you understand my viewpoint.
I do understand your viewpoint.
Thank you.
What I'm trying to
actually,
help
you really shouldn't mute Noah. He wants to express his thoughts, though.
Shush. So I'm trying to help you understand why we say the vacuum of space doesn't exist, and it can be understood in very simple laws of nature that happen always and at all times. One of those laws of nature is the second law of thermodynamics, which means entropy will increase. It can be described in several different ways. Hot will go to cold. High pressure will go to low pressure. The reverse will never happen. You see, the thing is, having the Earth as an open system, open to the vacuum of space, with gas pressure, is a direct contradiction of those laws.
But how?
To have gas pressure, you require a container, a physical boundary for the gas to press against, as exampled within PV equals nRT, where P, pressure, is solved by force over area. Area is a physical boundary given in feet and meters for the gas to press against. If the Earth is an open system, then there is no physical boundary for the gas to press against. So we would not be able to achieve pressure. The second problem is, if there is no physical boundary, entropy will keep increasing, as in the gas will keep dispersing, as in we wouldn't be breathing right now because the gas would have dispersed into the vacuum, the volume of space.
Well,
hey, can I ask you a legitimate question, Jedi? So, do you agree with Copernicus's idea of a heliocentric galaxy, per se, or solar system?
At the moment, we're trying to help this young lady understand that pictures from space are not real because they violate laws of nature.
Yes, but also the issue is with being an autodidact, which
I'm going to persevere to interject.
I've interrupted
not formed question to begin. Sorry,
I've interrupted this young lady, and I don't want to keep doing it again. I'd like to keep her on the other end, so we can reach the conclusion to this topic.
I had one question. It's stating back to kind of what Dave the Pickle just said, right? Your sources. Again, earlier when I mentioned that these people, they have gone to school for years. They have actually been to space. They've studied. They brought stuff back to Earth, and there is a lot of proof that this stuff. There is a lot of proof that this stuff does exist, right? So they have their sources. They have their evidence. Where did you get yours from?
Okay, so PV equals nRT, Avogadro's law, Boyle's law, Gay-Lussac's law, the common gas laws, kinetic molecular theory, the first and second laws of thermodynamics, things that anybody can understand with a basic education. Now, if these people have said that they've been to the moon and come back with rocks from the moon, then that's in direct contradiction to the laws that I've just mentioned. These laws, like Avogadro's law, Boyle's law, Gay-Lussac's law, are experimentally validated. As in, every single time you talk about gas pressure, you're going to require a container. If you don't have a container, the gas will increase in entropy and disperse into the next available volume. So when they turn around to us and say, we've been to space and taken pictures of the Earth, we understand that that's a contradiction to those laws.
Okay.
And let me ask you this. Let me ask you
this
this very simply. Can you demonstrate gas pressure without a container?
I'm actually not too sure, and I will admit that. I don't know too much about when it comes to that kind of science, because I have not studied that yet. So I apologize. But I still do stand on my point that the Earth is round, and I do appreciate your viewpoints, though. I do appreciate your points that you gave, but I simply still am not convinced, but I will probably end my thing here. But thank you for talking to me in a respectful way, sir.
That's not a problem at all. Just remember that we measure the Earth to be flat.
And also remember that we've measured the Earth to be round. Thank you.
Have we? Okay, so can you give me the direct measurement of the Earth being round then?
What do you mean by that? Like the diameter, the circumference?
Yeah, whatever measurement that you've got, can you show me how that was done?
Well, when they go to space, they can. So, for example, when you go to space, right? They launch the rockets into space, and they can measure the distance from the Earth. And from there, when you're at like a distance away from an object, you can kind of measure how big it is by, maybe using your hand or just giving like a wild rough estimate. That's probably how they did it.
So they figured out the Earth and its dimensions when they went to space, and not before.
How would they figure it out before if they're on the ground?
Well, this is what I asked you. So apparently, according to you, we only figured out the Earth and its dimensions in the 1960s when we went to space. Is that true?
Not only, I'm not too sure if they did or not, but most likely if they go from a 3D perspective, that's most likely how they got a better number. They could have had an estimate beforehand.
Hand measurements.
Yeah, hand measurements do work sometimes.
Okay.
It's got to be the silliest thing I've ever heard.
I just want to say, Jedi. I just want to say, Jedi, you explained it perfectly, but it's almost like those who get it are going to get it, and those who don't, they're not. So I just want to throw that out there.
Oh, I know.
Good job, brother.
Crystal, let me ask you this concerning what Jedi told you. Do you understand that his argument is a reduction to absurdity argument? He's trying to explain the false implications of the cosmic paradigm that you believe.
What did you just say? I'm sorry, could you repeat that?
He gave a particular argument concerning what would happen given the observed and established law-like behavior of gaseous matter, and that the cosmic paradigm you believe imply falsehood as it concerns the nature of gaseous matter, with specifically the second law of thermodynamics manifest.
I understand what he said, but the main thing that I keep going back to is that there is quite physically and literally photo and physical evidence of the fact that they went to space and did come back.
Okay, so this is the problem. So let me add this to what Jedi explained to you. So after his reduction to absurdity argument concerning the false implications that your cosmological paradigm implies as it concerns the natural behavior of gas, you believe, correct me if I'm wrong, that there's this universal gravitation, correct?
Yeah.
And you believe that mass is attracting mass, correct, in that sense?
Mm-hmm.
Do you also believe general relativity and special relativity?
Elaborate, please.
Very simply, the early 20th century doctrine from Einstein, GR and SR, general relativity, concerning the curvature of space-time because of the existence of matter, and then special relativity concerning that no matter where you're located in free space whatsoever in the cosmos, you will never look like you're at the center or at the extremity. It all looks the same. So, there's that.
Is that the thing where it's like the path of light will follow the curvature of space-time as it passes near a star? Is that what you're talking about? I'm sorry.
That's included. That's included.
Included.
And so there's that. So you have two major historical precedented theories, doctrines as it concerns what causes things to fall and what causes things to stick to one another so that everything isn't flying around or clumping together. So this is the problem. The hypothesis that is implied by that premise is that the sheer existence of matter is the cause, the independent variable of the effect, the dependent variable, which is things falling or things moving. So as it concerns mass attracting mass, you have that premise where supposedly the sheer existence of matter is the cause of other matter being pulled to other matter. But no one can manipulate the independent variable. No one can cause matter to discontinue existing and resume existing. So you can't manipulate the independent variable, which is required to see whether or not that independent variable in the hypothesis is going to manifest the effect, the dependent variable. So you can't verify that hypothesis. No one knows. No one can know that doctrine to be true. But it's even worse than that. As it concerns a locomotion, motion through space, you're either moving away or toward or not at all. So after the primeval atom expansion, all material particles are either expanding ad infinitum so that everything is disintegrated from one another, but that's a false implication. We don't live in that world, so that which applies falsity false. Or all the material particles will clump together in one humongous clump. We don't live in that world either, so that which applies falsehood is false. Or everything will be completely idle. We don't live in that world either. That which applies falsehood is false. So not only is it unverifiable, but it implies patent absurdity by necessity. That's mass attracting mass. Do you follow me so far?
I am trying.
I know it's a bit much.
No, it's not that.
I try to say it succinctly.
It's just the fact that it's 3 a.m. in the morning for me. I'm just a little tired. I'm sorry.
That'll do it too.
Can I take a stab at it?
But do you also? I would also kind of just point out like Kepler's 3 laws kind of just disprove all of this.
Disprove all of what?
No, they don't.
They really don't.
The planets move in
argument that I just
orbits
said?
with. Yeah.
Tell me Kepler's 3 laws so I can understand you.
Planets move in elliptical orbits with the sun as the main center of the focus. Planet covers the same area of space in the same amount of time no matter where it is in the orbit, and a planet's orbital period is proportional to the size of its orbit.
But the thing is, all those 3 laws I can already tell being logically consistent with this cosmological paradigm, those supposed 3 laws are contingent upon the manifestation of this universal gravitation. So you don't have those 3 laws, as it were, concerning the planets and whatever other celestial bodies if you don't have this universal gravitation. And you can't have this universal gravitation given the reduction to absurdity argument that I just gave.
Kepler's 3 laws can be very well used when we talk about things orbiting the sun. The Earth doesn't have to be included in that, though.
Let me take a stab at this. I want to try to tie it back to the original argument. Now, we're talking about gravity because they say that gravity is the container of the atmosphere. Now, when we talk about the real world versus the theoretical astrophysics, I find that when the rubber meets the road and we're talking about the real world, some of this theoretical stuff just melts away. For example, if, let's say, your grandmother asked you to make her a steak on a propane grill, and it was her Mother's Day or her birthday, and you really wanted to do it, but she said, when you go buy the propane, you can't buy a container. Like, you wouldn't be able to bring the propane home and hook it up to the grill because you can't have gas pressure without a container. Now, you could bring the biggest and heaviest rock with you and bring as much gravity with you. You have infinite trucks to bring infinite rocks. You're still not going to have enough gravity to contain that propane. So when the theory meets the real life, the theory falls apart. You absolutely need a container for the propane. Does that make sense?
I'll just liquefy the propane.
Still going to need a container.
How do you liquefy propane without a container?
Cool it down.
Okay. Where was the propane when you found it?
In the ground, presumably.
In a container in the ground? Contained in the ground?
Something like that, yeah.
Okay, so you need a container.
Yeah, okay, yeah.
Because you can't cook the steak on the grill without the propane accessories. You can't just go buy propane, no matter how much gravity you got with you.
Crystal?
What if I have one Earth mass available? Will that work?
You do. You do.
You do.
Yeah.
And if you open the propane tank, guess what happens to the propane if it's 250 psi inside the tank?
It will disperse in all directions.
Yep. So here on Earth, where all the gravity is, gas moves freely and randomly in all directions. So observably, gravity isn't affecting the
still
gas.
breathing something, so...
No, observably, where all the gravity isn't affecting the gas because the gas moves freely and randomly in all directions.
Except for the gases that are subject to downwards accelerations, like sulfur hexafluoride and...
Okay, so sulfur hexafluoride, that will be a relationship between that denser, heavier gas and the atmospheric gas. So that gas will sink. But if you put sulfur hexafluoride into a vacuum chamber, you have a container without any gas in it, you put the sulfur hexafluoride into it, it doesn't pool at the bottom, sunshine. It disperses freely and randomly in all directions, pressing on the limitation of the container upwards, outwards, and downwards. So gas fills space.
So you run into a problem there, Jedi. That means that...
I didn't.
And by the way, so
hold on. Yep, hold on. So, and guess what happens to that sulfur hexafluoride in that container in the vacuum? It'll all equalize and reach a uniform pressure. So
in a container, yes.
Yeah. So
Thank you.
if the Earth is contained, then why doesn't the atmosphere all equalize?
Because we live in a dynamic system.
All right, and how does this dynamic system explain the pressure gradient that we have?
Oh, temperature.
But I can't predict the pressure gradient with temperature, but I can predict it with G.
That's lovely. But within your
how does that work?
The reason how we can demonstrate in a contained environment a gas pressure gradient is to vary and manipulate the temperature within the system. Now you can have a gradient when you have radiated heat from the surface of the container, like the surface of the Earth, that radiant heat given by the sun, and you will have a pressure gradient. You can demonstrate this all day long with inside a container and the very manipulation of temperature. It's actually with inside your model, reason why you have an atmospheric gradient. It's demonstratable as well, experimentally validated. You're going to need a container though, because if you don't have a container, you have no set volume. The gas is free to disperse in all directions until it meets another physical boundary.
Well, we don't observe a consistent temperature increase or decrease with altitude, so that wouldn't be your explanation.
Do you know that you've got two gradients? It's not just a vertical one, there's a horizontal one moving away from the equator.
So
you need to know that as well.
Yeah,
horizontal. It's because it's to do with heat, dude.
Yep, so why does the heat go down, or why does temperature go down as you increase with altitude, then it goes up again? And then down again? That's kind of weird.
Yeah, that's phenomenal. But we are going to be varying a gradient with temperature.
Yep, so that wouldn't explain, temperature wouldn't explain that gradient if we observe the temperature go down and then up and then down again. Yeah,
does
so you're going to have to come up with something else.
Go up again? Is that in the thermosphere, is it?
It goes down and then...
It goes up again as we get closer to the thermosphere. Yeah,
25 kilometers.
Diagram for you if you want.
You can
Would you like me to post the diagram for you?
Yeah, sure.
Okay, no worries. But it's going to be temperature.
We're digressing from the premise where he's obfuscating the fact that I just refuted his ad hoc rescuing device with universal gravitation, so he doesn't have his universal gravitation in order to have gas wrapped around the ball, and then pretends as though we can't have the aerodynamics and gaseous behavior like we see with any container, which is what you need in order to have the gas do what it does. So why entertain that?
So if it's not affected by the constant downwards acceleration, then why can I predict its pressure with altitude by using G?
And I may add all that just to chase the poor Kepler lady away. Great job, Trig.
Yeah, that's also what I got. Yeah. We digress to the bigot from her. For what?
She'll be back. She said it was 3 a.m.
That is true.
Good point.
So again, like, we have a choice. Either we're just going to keep going to the inane circles with them where they just obfuscate the issue repeatedly, or we can just stop where they obviously start doing that. You don't have your ad hoc rescuing device for your gas wrapped around the ball in a cosmic vacuum. You only have verification of gas exuberating pressure on a sufficiently solid container. So all the gaseous behavior that you observe is within a container, and if there was no container, which is necessary for us to have the gas remain where it is so we don't suffocate to death, then we would suffocate to death and not have this debate.
Yeah. Also, as far as I know, aren't Kepler's laws just like kinematics? They're not really taking into account the forces involved anyway. So
that was just
like,
baby cover, yeah.
Yeah, but like invoking it doesn't mean anything because we're literally, when we're talking about kinematics, we're looking at things from a point of view, i.e., the Earth, and we're asserting that the Earth's a globe, and then making those kind of mathematical laws based on that assumption, right? So that doesn't mean anything. It doesn't prove anything.
Your descriptions is not necessarily indicative that they are correlative to what they're supposedly trying to describe.
I have an earnest question. Oh, go ahead. Sorry.
Yeah, go on. I'm just saying it's a waste of time.
I was gonna say I have an earnest question here, guys. Like literally.
1 second.
I was like, my bad. Go ahead. I'll mute myself. Go ahead.
Just quickly. Yeah, so it's just a waste of time to bring kinematics up anyway, because many people on both sides they'll say that there's kinematic equivalence anyway. So what are we even discussing at that point?
Yeah, it's a digression to just aerodynamics and, like you said, kinematics.
Appeal to physics fallacy. Yeah.
Yeah, digression from the premise called a red herring fallacy.
Yeah, kinematics isn't physics; it's maths.
I have an earnest question. Has anybody independently verified these extreme changes of temperature above a certain altitude to where it gets that hot? Because I know that there's a lot of weather balloons like that have independently been sent up, and all they register is just a freezing temperature. Has anybody ever, and I ask this honestly, like not trying to be flat or globe, I'm just saying, has anybody ever set something so high?
It'd be hard to. Hold on. It'd be hard to because the thermosphere reaches temperatures up to 3,800 degrees Fahrenheit. So whatever material you're sending up, if it reaches those temperatures, you're gonna fry that shit.
Nope, that's not true at all.
Well, that's what. Well, hold on. So Trig, your like core belief in the thermosphere's temperatures based upon just what we've been told they are without an independent actual capturing of it?
Nope, there have been independent capturings of it. Yep.
I please post them. I want to see it. Like honestly.
Yep.
That was like my earnest question. Like I've never seen anybody like send a independent a balloon with a thermometer and say, oh wow, the temperatures are increasing beyond a certain level, other than the textbooks telling us this is the temperature at that height. But has anyone verified that?
Well, all right, this has to do with NASA, but students work on it, so unless the students are lying as well with their university projects that they do, I mean...
Well, it seems that the independent experiments, to when they send something up, it seems to be that their balloons or whatever contraction that they're sending up, it always seems to like pop and then drop back down after reaching a certain level, but they never measure that heat. They just measure the coldness. Go ahead.
This is why we need flat Earth rocketry.
Well, I mean, I don't know, bro. Like, just if you could please post something that's independent. Like, come on, bro.
What is
like,
independent to you? What is independent to you?
Meaning somebody besides NASA, somebody besides the textbook, somebody besides somebody that's saying this is what is. Well, has that been verified?
All right, temperatures in the upper atmosphere can range from 932 degrees Fahrenheit to 3,632 degrees Fahrenheit or higher. So yeah, I was off by a couple hundred degrees, but
no, cool. I get it. I know that's what we've been told, but has somebody verified that?
Bro, give me a second. So he was wrong when he said that temperatures don't get up that high. And you tell me what material that's lightweight doesn't melt at that temperature.
Yep, so I can explain. So you know that temperature is obviously just the average kinetic energy of a molecule, right?
Right, and if you're sending up solid stuff, it has lots of molecules, right?
Yep, so if I have, let's say, so the density of the atmosphere up at that altitude is going to be ridiculously low. So it's equivalent to saying that a couple of these molecules are going to be hitting the metal, like maybe 100 individual molecules are going to be hitting the metal, but they're going to be going really fast. Do you think that should melt it? If there's like a few hundred of the molecules out of the trillions of atoms inside of the metal?
No, but it's not just the molecules; it's also the photons, right?
The photon, yeah. Photon heating. I mean, sure, I guess, but are we getting cooked down here too? I mean, sometimes, yeah.
The fuck is he talking about? Heat is heat.
Cooler. Yeah, we have a cooler temperature. So what he's saying is because the heat coming from the so-called gas, which is the temperature that we're quoting, right? It's so sparse that it's not going to heat it up. And I'm arguing, well, it's not just that going on up there. You're also getting a direct hit from sunlight with very little protection of atmosphere. It's the equivalent of being at the bottom of the ocean and going, hey, I can't see a whole lot of sunlight, as to being at the surface of the ocean or right under the surface and going, well, the sunlight's lighting up my retinas and I can't see because I'm acclimated to being lower. So what we're saying is that if these temperatures are real and the sun is hitting these things, causing these temperatures, whether it's a few molecules from gas particles or a sheet of balloon material, it's going to heat it up until it causes it to break down. That's a lot of energy. 3,800 degrees or 3,600 degrees. That is a lot of freaking energy.
There's also very low mass, Larry. So the ability for something to heat, so the heat of something is proportional to its mass times its temperature times the specific heat of whatever it is we're talking about. So if you've got a gas that's near vacuum at 2000 C, its heating capacity is very low, so it won't be able to rapidly heat up an object that weighs 10 kilograms is made of aluminium. And it's quite likely that the rate of radiation of heat off that object will be faster than the heat from the thermosphere.
What's it going to radiate into if it can't, what's the word, conduct? It's not conduct, that's electricity.
It's just pure radiation of heat.
If it can't radiate the heat, hold on, if the atmosphere can't radiate the heat into the object, how is it going to radiate the heat out of the object if the molecules can't carry that temperature? We're talking about sunlight hitting an object. So if you send up aluminum and it's getting bombarded by the sun and those temperatures reach up to 3,600 degrees, that aluminum's going to melt after a while because it can't radiate the heat off of it. So your argument... Hold on.
Stop
Bro,
saying bullshit that you don't know about, dude.
Can I finish?
Nope, because you're just saying wrong.
So you're not going to let me finish?
No, because you're just lying.
So I'm lying. Okay. How am I lying? Because I'm going to let you answer this question. I'm going to mute you in just a second, Trigonometry Man. How am I lying? I said that the sun is going to heat up objects that are packed with molecules like aluminum up to 3,600 degrees. How is that incorrect?
Because you're saying that they should melt because they can't convect the heat. I'm saying Stefan Boltzmann law.
Okay, go ahead.
Stefan Boltzmann law is invariant of what medium it's in, right? It's just the proportion of the energy radiated from a black body is the temperature or the thermal emissivity of the object, and then temperature of the object to the fourth power.
Okay, can you put that in English?
What did I not? Do I need to teach you about physics too?
Nah, say all that again.
You're saying I'm lying, right? But I didn't hear the part where you pointed out that I'm lying.
Oh,
And
just by
shove the
saying that it
question on
wouldn't
your nose,
convect, that it
please.
wouldn't convect, that it wouldn't be able to.
So the sun doesn't heat up objects to 3,600 degrees, but it heats up the molecules, which are kind of like objects, up to 3,600 degrees.
Yeah, individual molecules, not bulk matter.
Okay, so what's the difference between individual molecules and bulk matter if the ISS has been up there for 20 years?
First of all, the ISS is coated with white paneling, so it has very low thermal emissivity, right?
So low for 20 years? Okay.
And it also has radiators on it too, so yeah.
But there's no atmosphere to radiate into, like you guys were saying at the beginning.
Stefan Boltzmann law.
So what is it radiating into?
Yeah, you can radiate into a vacuum, Larry. There's the couple of ways of losing heat in a spacecraft. So one that we don't have is convection, where air contacts and carries heat away. But radiation can happen into a vacuum. That's just heat radiating directly out. There's no medium required for that.
So does heat radiate out from the sun onto this material?
It does, yes.
Oh, okay.
So the challenge for spacecraft is to balance that. So you've got a small amount of energy coming in directly from colliding with the particles around you. You have direct radiant heat coming in from the sun. And then the only mechanism you really have to get rid of heat is radiating heat out. In some circumstances, like astronaut spacesuits, they actually are able to effectively freeze liquids as well. But for a spacecraft, the only mechanism is to radiate heat out. So they typically pump the heat from one side of the spacecraft to the other and radiate it out into space. And the challenge is balancing that rate.
So let me get this straight. The sun radiates heat out and it hits the material and the material doesn't heat up.
It partly heats up. So if it's highly reflective, so like Trigonometry Man said, if it's white or silver, 90 or 95% of the heat will just be reflected straight off.
Well, then, I'm pretty fucking white, bro, and I get hot outside.
Yeah. But you'll notice the difference, right, between a white painted surface and a black painted surface. That's the order of magnitude difference of the amount of heat that gets absorbed.
White. Right? White things get hot.
I'm not denying it gets hot, right, but it gets less hot and it gets hot slower than something that is black.
Concrete's pretty white when it's brand new, and if you walk outside in Texas in like August, barefooted, you're going to burn your feet.
Yeah. I'm in Australia. I know the deal of hot concrete. Yeah, got bare thongs. But it's the rate. So it's a balance of two things: the rate of heat coming in and the rate of heat going out. And the spacecraft has to balance that so that they don't freeze to death and so they don't overheat. And it is possible by not absorbing all of the sunlight that hits you to radiate enough out to maintain a stable temperature.
How? How are the solar panels doing that?
Solar panels.
I think they're actively cooled, Tim. I think they actually circulate coolant through solar panels up there.
No. The ISS uses
radiated
propylene glycol through and ammonia.
Can I throw out a logical question for you guys?
If it's from APOC, then it's not going to be logical, but sure.
So if you think about like an oven, right? And there's like this heat, and I get it. You could put your hand in the oven and it's not going to like burst into flames because there's this radiant heat within this confined space called an oven, right? But how do you measure 3,600 degrees to when the particles are so far away from one another in the highest of the sky? How do you measure that heat if they're so far apart? How does your thermometer pick it up if they're dispersed. It's almost like saying if I turn on an oven, but there was no walls on it. So, but you had now the oven is like just open, and now your whole house is like an oven. But you're not going to reach that temperature because technically, what creates that temperature is the size of that area. So the,
All right,
the
let me
smaller you
translate.
get. Oh, go
Yeah,
ahead.
it's difficult to measure temperature.
Hold on. Let me translate for the guy. What the guy's asking is, how did the thermometer ever reach 3,600 degrees Fahrenheit?
They can't measure it with a thermometer. It just wouldn't get hot enough.
Okay, how do they measure that temperature?
I don't know exactly, but I know that you need to use special techniques to measure temperatures of sparse gases. It's like trying to measure the temperature of a vacuum, right? It's hard.
Okay, no, I know, but that's kind of the point. So, like, if you have an instrument, fuck a thermometer. We just have an instrument that's somehow is going to register a temperature. But if the molecules themselves at that altitude are supposed to be so far apart from one another, how can you register that heat? Because technically, what you're measuring is when they're close together and they're able to produce this measured temperature. Yes or no? You know what? Go sit on that. Think about it. And come back to me. I don't know. Do a report. Come back to me. Maybe I'm an idiot, but let me know.
It's a good question, Apocryphon. How do they measure that temperature to begin with? Because these guys are like walking down this temperature as if we don't really have that temperature because of the atmosphere. Well, how do we measure it to begin with?
Yeah, I think they do it optically, right? Optically or with radio waves that you've got to, because there's not enough there to heat anything up. You can't
not
measure
radio,
the heat transfer.
LiDAR. They use LiDAR.
Light, do they? Yeah. So basically measuring the Doppler shift of if you're doing it from the ground or wherever, but yeah, measuring frequency shifts caused by so temperature of a gas is related to the velocity of the gas particles or the average velocity. So if you shoot light in there, you'll get Doppler shift in the reflections that are coming back. You'll be able to measure something about the speed of the particles, and that's how they deduce the temperature.
So you're saying that the speed of the particles that are like 1/1,000,000th within a cubic square foot, like you're saying that one particle, they're measuring it and saying, oh, because it's this rapid, speed in itself, you're saying that's how they're picking up the difference from what they can and do measure. So, like, let's say you send a weather balloon up and you have a thermometer on it, and it's measuring, it's cold, but all of a sudden you can't go higher than that to measure that is all of a sudden climbing in heat. But you're just saying you use LiDAR, and all of a sudden you can get the measurement. Like, I don't know, that kind of seems far fetched, brother. Like, I could be wrong, but I'm just saying it's a little pseudo to me.
It's a non-trivial thing. I'll give you that.
Hold on. It's kind of the difference between touching hot oil in the oven at 500 degrees and touching the hot air in the oven at 500 degrees. So the hot oil is going to burn your ass, baby. Don't do that. But the hot air, you'll be all right because it's not very dense. We'll keep on going like orders of magnitude less than that because there's that much less air up there, allegedly. And you can touch air molecules that are sparse at 3,800 degrees and not burn your ass. That's what they're saying. So it's not like innately comprehensible, but if you think about it for a second, it does kind of make sense because hot aluminum doesn't burn your ass like hot iron.
That old question, like, we tell people, well, you can't even go to that height because every thing that's made out of these satellites or whatever, these rockets, whatever, it would melt technically here on Earth. It would melt if you introduce it to the heat. But they're like, you don't understand heat. When it's so spread apart, you can still go into the environment and not get burned. Okay, I get that. But then if it's so spread apart, how do you get a measurement from that? How? But I guess you explained. You said, "Oh, you just use LiDAR and you can know the part." I don't know. It just seems very pseudo to me. I mean, you
see that molecule over there hauling ass, going like.
You doesn't believe it, I guess. Trust me, bro. It's a trust me, bro situation.
It's obvious, man. One at a time, right? One molecule at a time, right?
Right.
Yeah. Sorry if I'm wrong, but I was pretty sure I read something about them using LiDAR to determine density and temperature and stuff like that. But they could use radar. I'm not sure.
I think the wavelength's got to be short. I think you're right, Tim, there, that it's got to be optical. Ultraviolet is the reference I found, that they light it with ultraviolet and measure the scatter and measure the frequency shifts in the scatter. But going back to everyone's favourite, ideal gas law, the definition of temperature there is related to the average kinetic energy of the molecules, which is related to their average velocity. And trigonometry man's mate, Mr. Boltzmann, also came up with a relationship there as well.
Okay, so let's think about this. Hold on, So let's think about this. So up there in the thermosphere, these things are hauling ass, right? These particles, molecules, whatever, atoms. The gas is hauling ass in the thermosphere. So as it approaches like the exosphere, it's going to be, really hot and hauling ass. So we've been losing atmosphere for 4.54 billion years, and we haven't lost it all already.
So we lost some. There's definitely a net exodus of gas out of an exodus of gas out of the atmosphere. But the key thing is, back to our the laws of thermodynamics, that as things get higher, they gain potential energy, which means they must lose kinetic energy. So
But Dazza, that goes back to, let's say you created a spherical somehow. I don't know how you can do it, but let's say you create like the sphere rock, right? And you put it in a vacuum and you put gas around it. The second you turn on that vacuum, all that gas is going to escape that vacuum, and that rock is just going to be a rock now. There's not like, you have to admit, you're not going to have gases in that vacuum no more, because and that's for your whole paradigm. Everything about it, like every planet that you think has an atmosphere in its own little, position, like all the gas would be sucked out and dispersed by law. So why do we still say, no, but we have our little gas ball here called Earth? Like, why? I'm so lost.
It's just not big enough, man. It's just not big enough, right?
I don't know. Like, oh, bro, listen, it's kind of weird. Just kind of crazy. You just have to trust us, bro. Like, it comes down to that. If we cannot,
everything else that we try to lift up takes energy, right? Anything else we try to take up high, we need to do a lot of work to push it up high. Right. Why would gas be any different? That if we take a gas molecule fuel from the surface of the Earth and want to get it up into the upper atmosphere, why is it different to any other massive object?
No. Okay, with that logic, Dazza, Dazza, what happens if you were to open up a soda can at 120,000 feet in the air? What would happen to it?
It would probably open by itself because it's
right. It'll pop. It'll explode.
Yeah, exactly. Yeah.
So because it's trying to equalize itself. So how, in your paradigm, does the Earth equalize itself around a vacuum of 10 to the negative 17 torr?
Can we just round that down to zero? So how does it operate next to a vacuum of zero, right? 10 to the negative 17, we don't even need to mention that. We just say it's zero. It doesn't make any difference, right?
Exactly.
What is it equalizing against? What is the equalization method? It's equalizing against entropy, right? That we're trying to get an entropic equalization. That's what
the example of the canister of gas. The gas inside the container isn't met with an equal opposite force by the pressure outside. So that's why it's expanding. The gas can will pop.
Yes.
So our gas that isn't met with an equal force out there is free to disperse into that area.
Exactly, Jedi. Bullseye. Bull fucking zai right there. That exactly. You cannot say that it can exist at this point, because it wouldn't. Like, by law, it wouldn't even be a viable environment. It would what's the word? Not drastically, violently, it would expand to equalize. But you cannot have this fake space like boundary without it like having a literal like effect upon the gases next to it. Like, I don't know, bro. Like, Why are we here? Why are we discussing this? It should be common sense.
But what is equalization, though? Sorry, I didn't mean to cut you off. Finish.
No, it's okay.
So what is equalization of gases, right? It's when they find some balance in the entropy with them and the system around them. And typically, a gas in any kind of equilibrium state is in maximum entropy for its situation. And in the upper atmosphere, the entropic equilibrium is satisfied, right? So if you opened your can in the thermosphere, it would scatter and it would spread out far and wide, right?
Right.
And eventually, some of it would be exchanging that kinetic energy as it expands out fast, the potential energy as it goes up higher, and you establish an equilibrium.
But if that was
the
the
point of view
case,
of thermodynamics.
But if that was the case, Daza, then everything about the air you're breathing right now, you wouldn't have in your lungs, because it would have, by law, dispersed already to equalize around the vacuum that it's in.
Well, gas can exert pressure on itself, right? That's why we've got these layers. The pressure gradient, right, is gas pressing on gas, right? So that's one mechanism.
Only in a contained environment. It's going to depend on the volume the gas exists in. Because if there's no volume or container for the gas, the gas is going to press against itself, but it's going to continually press less and less against itself because the gas is dispersing into more space, so there's more space between the gas molecules.
Yeah. Eventually it will stop in a situation like the Earth, because...
How will it stop? The only thing that stops it is the physical limitation of the environment that the gas is in, i.e. the container. That's the only thing that stops gas motion.
The first law of thermodynamics stops at Jedi. So you can't continue to raise the potential energy of a gas molecule without sacrificing kinetic energy. So the gas will slow down as it goes up and stop expanding.
Okay, so going back to the vacuum in a classroom setting,
that's not true.
How do you have a ball of gas to exist within that vacuum? Like how can you justify it that the gas wouldn't it wouldn't disperse? It wouldn't go to the space that it's trying to fill. Like how do you guys still hold on to that?
And can I add to that too? Like, isn't there also a claim that the sun is burning up 10 trillion tons of whatever helium or hydrogen or whatever per day, right? Like, how does it not, how is it still here if it's been doing that since its inception, right?
So why is the sun not smaller?
Point.
It just sounds like we have to just believe.
Hold on, Apocryphon, just real fast. Think about the formation of stars, right? When you take a look at these gas laws, right? How would there be gravitational collapse of stars to begin with? Because we're talking about so-called nebulas or some sort of let's say supernova, right? Spews out all this gas. Like, how would it ever gather up into one spot and collapse back down on itself? Like, the whole gravitational collapse doesn't really make sense anyway. And then they're saying that basically the Earth has enough gravity to cause gravitational collapse of an atmosphere to the Earth and to stick onto it. Now, it can't collapse all the way down to the center because the rocky surface keeps that from happening, but it collapses down to the surface. I mean, that's just insane to me.
Exactly. It just doesn't make sense. Like, it doesn't. You only have to just believe what they have told you. This is what is, and that's kind of the whole argument. Like, why are we still stuck in that paradigm? Not us, obviously, because we understand it, but how is a glober still stuck in this paradigm if it doesn't make sense, even within the laws of physics, in the gas laws? Like, it just doesn't make sense. But they have to hold on to it, obviously, because this is what it is. It is what it is. But I don't know, man. Like, just think of it logically. Just use your brain, bro. Like, just question it. Like, get rid of the bias and just question it. Say, wait, hold on. That doesn't make sense to any human being with a brain. That doesn't make sense at all.
And let's never bring up the Earth is moving in a particular direction, and this gas is staying attached to it whilst it's rotating and moving in a direction. Let's never bring that up.
Oh no, I'm just an idiot, I guess, with some stupid ideas and thoughts. But hopefully, a Glober that's listening, hopefully it sparks a fucking. Hopefully, your synapses are just cracking off right now, saying, "Wait, that is a question. How does that work?" Doesn't make sense.
Oh, I know why. Of course, it's just refraction, right?
There you go, refraction. Yeah, it destroys their paradigm, and those who get it. Those who don't, they don't. Hopefully, in time, they do though. Hopefully, a light kicks on, man. They understand the questions we're asking as to why we have this position, saying space is fake. Here's why, XYZ. But hey, it is what it is. Let's get back to the shape of it.
I'm curious to see if Jekyll or Matt will open up their mic. Oh, Jekyll's not here. Matt is, though. See if they'd like to explain to the room why the newly coined term, their words, not mine, McFraction, right, is not a plausible justification as to why some of the phenomena that we see in their proposed images is not how do you put it, is unfounded. Maybe if we can get another interpretation into the room.
What's McFaction?
It's the term that Jekyll and Matt think they're funny for inventing after they brought in a photo of two boats over the horizon. One was 8.6 or something like that miles out. The other one was 12 or 13 miles out. And there's a drastic difference in what we see, right? So the one that's closer is obviously not obstructed. And the other one that's further out appears very low, right? It looks half below the surface, right? And it was brought to the room in here as like, oh, well, how could this be explained? And I, not knowing any of the data, not knowing any other information, just threw out there, hey, maybe, I don't know, like you guys throw in here all the time, a reason for why things look weird out in the distance is refraction, right? So I threw that. So I just threw that out there as a proposition, and they think they're funny. They think I'm, making shit up. So all of a sudden, there's a new term coined. You mean unlike everything you guys do all the time, every day, consistently?
Name one thing we've made up. It's
like everything. Like everything.
Name one. Name one.
The globe. The globe.
Made up ever.
The globe, curvature, gas pressure without a container, bendy, warpy space time. Need I go on? Right. So can you? So you think, right? So is McFraction, I guess, right? I can say that too.
Made
right?
up by you. Yeah, you created it like 2 days ago.
Yeah, yeah, sure. So how about you present your claim to the room and see if anyone else has any other ideas as to what's going on. So maybe we can discover something.
I don't think like
maybe we can discover something called the Jedi fraction or a Poc fraction or a Flatsy fraction. You know, like we're making. I guess what this room is all about is making discoveries, right? Go ahead.
What are you making up?
You made a new discovery like 2 days ago. It's great. We love it.
What? So you're not going to take my offer? Fine.
So Matt,
for what?
Did you not hear my request?
No, not really. Can you explain it?
For us to discover other refractions? I mean, sure. Can you actually tell Jedi what you thought so we can think about how dumb it is?
I'm asking. Yeah. Okay. Sure. So if you let me speak. So how about you first start with the claim, right? You bring out the photo and say that this is
You
Earth
start
core.
with what you think is a phenomenon. Go ahead.
Okay, so bring the photo into the room, and then we can talk about it.
Photos up top. Photos up top.
Up top. There we go. Right. So yeah, okay. So everyone can see, right? Obviously, this is under heavy scrutiny, right? And now I'm obviously internet famous, right? And it's funny because Jedi laughed, right? So how about that? Yeah. Anyone else in the room got any ideas? Right?
About what?
What could be causing this obstruction, right? Or so-called obstruction, or what else would justify?
They already have a name for it, man. It's called sinking. It's called phenomena. The refractive phenomenon is called sinking.
Oh, thank you very much. So you guys can retract this idiotic term that you coined on my behalf. Right?
No, we didn't retract. That was actually done by somebody else. There's actually a Glober.
No. I'm sorry. Forgive me. Like what I meant is towards Matt and Jekyll for coining the idiotic term with my name in it, all on my behalf, because I proposed basically the same thing, but now it turns out there's another word for it. So very good. Too bad you didn't trademark it.
The only issue we have here, Mick, is that whatever you propose has never been backed by anybody or any scientist, any biologist, anybody actually in any of the fields. So that's why it's kind of flat.
And that's your claim, right? So let's see if
is it my claim, or do you know anyone that's ever proposed this?
I made it abundantly clear that it was a baseless proposition on my side, highly speculative, because I don't know shit, obviously, right? So that's why I'm bringing it up, because maybe someone else in the room does.
Right. At least you cleared it up for us that it's not backed by anybody.
If it was unclear up to this point, you have not been listening, and I guess that's obvious.
No,
right?
it's been clear. It's just that I want to make sure everyone in the room knows that no one backs this, right?
But Matt, like honestly though, would you agree that everything that you are introducing is just based upon like this mathematical claim as opposed to reality, observable,
all I'm
and
claiming,
physical?
So all I claim is refraction when we see things obscured.
And we agree with you.
I can back this. I can show. Hold on. Like Gregory would say, right? Don't talk through the reply. But all I'm claiming is stuff that I can back. Like I can show you something being obscured bottom up, or not bottom up, but coming over a curve, right? Okay. I can show you something coming over a curve when you change the density of the air. I can show you that.
Okay.
I can show you that with refraction. Okay. I mean, what he's demonstrating, he can't show. Something different, right?
Well, hold on though. If you could ask my question though, can you at least earnestly admit that everything that you bring to the table is based more upon a mathematical equation? Yes or no?
Well, wait, refraction? You don't need any math just to know that refraction's a thing and it can bring things from behind a curve. Yeah, you don't need any math for that.
So you're saying that you're okay. So when you guys have this model and you like introduce refraction, you're saying it's not a mathematical sliding bar? I would disagree with you, brother.
You can do math with refraction and then be like, okay, there's going to be 0.0.72, whatever it's going to be.
It's math. So it's math
at this degree or whatever. You can do that. You can also just show refraction and show things being brought back from the curve. You can do that as well. You don't need math to see refraction or to understand it.
Look, I agree with you, but I'm just trying to see if you will agree of your own point that it is just mathematical.
It's not just mathematical, though. This is a thing that we can
So
quantify.
you're saying
hold on,
what is quantified?
Hold on, Apocryphon. Hold on.
Mathematical.
Hold on. This is something just like everything else that we can quantify, but it's not just mathematical. Like refraction is an actual phenomenon.
Right? Absolutely. But when you take refraction to these extremes, is that not just a mathematical position? Yes or no?
Dude, what do you mean it's like we're not making shit up? So it's not just mathematical, no. It's not. This
Oh
isn't
my gosh,
theoretical physics, okay?
you're not getting it, bro. You literally just said we could quantify it. Does that not mean you're
Just
mathematically
because we
making
can
it?
quantify Apocryphon, holy shit, man. Just because we can quantify something does not mean that the actual phenomenon is not an actual thing.
I'm
It's
not.
just
No,
us
no. Hold on.
quantifying
Look at.
how much would this be sloping, right?
Okay.
What's the degree of refraction via
Okay.
the air density?
Okay.
Right?
Degrees.
We can do mathematics with that, but the physical thing is still going on.
Okay. Once again, I'm going to ask this again. Would you at least agree
don't
that
ask the
what
same
you're
question, dude.
doing,
Don't ask the same question.
what you're doing is using a math to represent?
Dude, it's not my fault math scares you, dude. I don't like math either. It's fine.
You're not answering.
You're
not answering it.
Matt, you're not understanding.
It's not just mathematical. And Mick, you better not back this up.
Yeah, Matt. No. Let me talk. If I understand what APOC is saying, it's not that what's purely theoretical in this context is taking the known phenomena and drawing it out to extremes to find the points that have not been validated in reality to try and justify what's going on, right? So that's why he brought up the sliding scale, because you can take the sliding scale, right, on these calculators and stuff, and draw them out to whatever extreme until you find the number, the value that actually that mimics what is observed, and then it's claimed that
doing that,
and that all the refraction calculators do this, or at least all the ones I've seen. Right? You have distance, you have all these kind of parameters set in, right? And then there's a sliding scale that imputes the what the refractive index must be, I guess, on across the entire plane, the entire field, to justify what would be seen, right? The problem is when that is not.
Can you summarize?
Let me finish. When that value is never brought out into reality and tested that, this is actually what was going on, it is a purely abstract theoretical concept. Not that refraction itself is purely abstract. It's the value that is imputed that is said and claimed to be the case when it is never validated. That's the point.
Well said. Exactly.
Okay, so first of all, no, you can't let him say something to me and then you start talking. What the fuck is this?
Go ahead.
All right, so first of all, right, I don't know where you're getting from that we're making shit up. If you can find me where we're making shit up, I would love to see it.
Okay, so
where we brought up refraction numbers out of nowhere, I would love to see it.
Okay, so whip out your favorite refraction calculator.
What do you mean whip up? I don't have a refraction calculator.
There you go. So you don't even know where I'm talking about, right?
Matt, I
don't know what you're talking about. Show me where we've made it up. Show me where we haven't factored in any air density and have said refraction's happening. These are the numbers, and we're not accounting anything for the air density. Because that would be what would make this shit up mean.
That's not what I said.
That's exactly what the fuck you said, dude. When we're pulling up numbers to fix things that aren't there. Isn't that what you said?
No, that's not what I said. What I said is it's a known phenomena that refraction happens. But over large distances, okay, there's not probes out every, let's say, 100 meters or whatever, measuring the atmospheric conditions, right? And then taking all those data points and back propagating in a computer or whatever, and then calculating what the refractive index was at that time. Okay, that's not what's happening, right?
You take an image. That we're making shit up then. Yeah, exactly what I thought you were saying, dude.
Can you let me fucking finish? Or are you going to continue like what you guys have been doing over the last 48 hours? Right? This phenomena, what I'm talking about, by actually probing all the data points over the entire distance, right, is not what happens. People take an image, they know the distance, they observe a phenomena, and then they impute what the refractive index must have been throughout that entire course to justify what they see given the known parameters and assumed parameters.
Yeah, Mick.
If you don't understand that,
I don't think anyone gives a fuck enough to get probes in every inch. That's the only logical problem.
Well, see, there's your problem, right? So therefore, you guys are relying on the fact that no one's going to scrutinize to that degree, right? And you guys are going to rely on these assumptions.
You do it. You scrutinize to that degree if you want to. Go ahead, do it. You do it. Give us the data.
These are your claims.
Hey Matt, I'll mute myself after this.
If you're telling us the refraction's not causing something, then it's your claim too. It's
Hey,
your
Matt.
problem too.
Hey Matt,
You guys bring it up.
Hey Matt, just hold on, real quick, Milk. Just real quick. I'll mute myself after this. All I want to say is it's really weird that you're not admitting that it is a mathematical sliding bar that's trying to say this is why we are seeing something mathematically. It's really weird that you're not standing on your own position, because your own position is a mathematical sliding bar because it's a calculated measurement on math. It's really weird that you're just avoiding that, bro. Like I would say like if you were just being honest with us, like genuine, you would at least admit, yes, it is mathematical, because technically it is fucking mathematical. Okay, I'm gonna mute myself. Go ahead.
Oh my god.
See, so Matt, just to be clear, here's the thing. I don't think anyone here is scrutinizing the legitimacy of mathematics. Okay, it's a useful tool. It's accurate when done right, et cetera, et cetera. That's not the problem. The problem here is when we have too many unknowns, right? A handful of assumptions, right? And it just so happens to be the case that the opposite position decides to scrutinize some of these unknowns and points out that, oh, they are unknowns that have yet to be validated. So therefore, your claims, right, can only be held up in the air as, quote, valid only to a certain degree. That's all. That's all that's going on.
Okay, so I don't. First of all, obvious me is talking to me about some shit that I don't even know what the fuck he's talking to me about. But, yeah. I mean, the problem is if you want to say that. Hold on, Mick. The problem is if you want to say that refraction. If you're making long distance observations, right, and you are going to make a positive claim that refraction is not the reason why you're seeing these things, then you yourself is going to be the one that have to get all the probes out there and give us all the data that's going to be factually correct. Right? That's also a thing, because you can't claim this isn't causing this, but I'm not gonna account for this at all or test it with the probes. So it's basically on both of us. No, it's not reversal, because you're claiming. So either you take refraction when you go out and do these observations, or you don't. Because you obviously don't agree with me, right? You don't agree that refraction is the reason you can see these things, right? So if you don't agree with me, you got to get the probes out there too.
The only reason why I brought it up as
we're doing, bro. We're on the same boat.
See, this is the point, right? I brought it up as a highly speculative possibility, right? To illustrate how equally lopsided both sides can be, right? But you guys stand on the fact that, oh, this must be the case for absolute certainty. I am comfortable with saying I don't know, right? And this is where the asymmetry kind of reveals itself. That's all.
Man, I mean, I don't know. You brought up Mick Fraction. You said that you were an honest guy trying to find the truth, but you brought up Mick Fraction, and you still went from the other side, although it was ridiculous. So I don't know.
I told you about five times already. I don't know for sure. And you guys dogpile as if I said something that I didn't say.
You shouldn't have just said it. It was too ridiculous for you to say.
You guys asked me a question. I gave you an answer, an honest answer. And I still stand on it. I don't know. It's possible. Right, but you guys make the opposite claim that, oh, we know for sure. Look at this calculator with 4 or 5 different assumptions and unknowns embedded in it. But oh, it must be absolute. You see the.
What would have been an honest answer? Would have been the I don't know. That would have been the honest answer.
It's just really.
I did throw in there. I don't know.
How can you be honest about something you don't know about, Mick?
What are you talking about? If I say I don't know, it might be this.
If you don't know, if you have no idea whether or not your Mick Fraction is actually a thing, if you have nothing like that backed it up, you said it was a baseless assertion or a baseless proposition, right? If you have nothing to back it up, the most honest answer would have been I don't know. Not
I don't have nothing.
Baseless assertion.
But I don't have nothing to back.
It's not honesty.
I don't have nothing to back it up. We know refraction happens. Therefore, this actually might be the case. But I don't know enough to actually say for sure.
No, it's not. What's wrong with that? You said no one's ever backed that shit before.
No, what do you mean?
So Matt, just honestly speaking,
no one's ever backed that shit before. So you're a liar, dude. You're not honest.
So Matt, just honestly speaking, it's just really
you're
sus.
Pathetic, dude. You said you're honest, but you made up some shit that no one ever backed up.
So Matt, honestly speaking, Matt, it's just really sus that you're not agreeing to the fact that the whole process of calculating refraction is not mathematical. It's really sus.
Holy fuck.
How do you
Calculating
not get it?
refraction is 100% mathematical. So you're changing your shit up before, man.
Hang on.
You're talking
So
about
you agree
calculating
now?
refraction,
So you, no,
and
no.
we
So
were
you
talking
agree?
about refraction being a mathematical concept.
So
like, which one is it, dude?
So you agree now?
Guys. Sorry to interject.
Calculating refraction, of course, that's mathematical.
Okay, so when I originally asked you,
Wait.
go ahead.
I just wanted to point out.
Don't interrupt them. Don't interrupt them. Finish, APOC.
No, he yielded. Shut up. Okay, sorry to interject, but I did notice that Jedi unmuted and muted a number of times, and he's been polite enough to not interject. But I did want to give him at least an option to jump in if you wanted to.
No,
Not that
you're fine, guys. I'll jump in
This guy
a
literally
minute.
shut us up just for that, dude. That I can
Yeah,
easily
fine.
interject whenever he
We
wants.
can go back to APOC, and then we can go through the 5 different types of refraction if you want to.
Okay.
That sounds good. Just the point being is that refraction, obviously it's an observed phenomenon. We get it. But on a globar scale, it is, pun intended, scaled down to a mathematical equation as to why we are seeing these effects, these optical effects or phenomenons mathematically. So when you slide your bar, that in that bar is a mathematical equation. And my original position was, Matt, can you at least be honest that your whole premise is based mathematically? I think we would both agree with that, but for some reason you're like just diverting and like saying no, it's not. And at the end of
Highly specific here. What's mathematic? Highly specific.
That there's an equation involved. Is that fair enough?
It depends. There's not an equation involved for everything. So what?
Okay,
what is there an equation involved for?
Okay, but in your paradigm, when you are accounting for refraction, is there not a mathematical equation?
Now there is. Now you're being specific. Accounting for refraction. Yes. Now that's a mathematical thing.
Okay. Yes. That was the original question, brother. God damn.
No, it wasn't. 20 minutes. No, it wasn't.
Originally it was, my friend.
Your original question.
That's why I brought the slide bar up. For more or less refraction. The refraction will have an equation behind it, hence the slide bar going up. That equation is being used to show more refraction, possibly because of the density or the temperature of the atmospheric gradient.
Exactly.
So the only problem we had, Jedi, was that Apocryphon at first was bringing up refraction and just saying, well, refraction's just a mathematical thing, right? Well, no, it's an actual thing. And we can quantify refraction or how much it's going to be happening depending on the atmospheric density with math. Those are two different things. And I think he wasn't being highly specific because he's never being highly specific.
No, go ahead, yeah.
That's not how the Earth curve calculators work, though.
Talking about the Earth curve calculator, dude.
Okay. And where are you getting the quote-unquote math that you're using?
We're talking about refraction. We're just talking about refraction, whether or not he's talking about the concepts of refraction. That's it.
Right. So in this context, the Earth has a fixed geometry. Claim is the fixed geometry is blocking the bottoms of things. Flat earther comes in and shows an object well beyond the geometric limitations of the geometry. Rebuttal is refraction from the globar. Then they model it out in orthographic view using lines or an Earth curve calculator. That's how it's done. Next.
We also have other simulators that you can. I mean, sure, you use the Earth curve calculator. You can use that as well. But if we're just talking about refraction alone and the densities of it, or how much it'd be refracting in general, you can also do that based on the curvature of the Earth.
Well, yeah, you
given
could.
Radius.
Right, and so you see an image, do a little bit of geometry to see what you should or shouldn't see, and then you just retro-engineer refraction that you think would be necessary for this image to be seen and the Earth maintained being a globe, then you just say, well, this must have been the refraction for that day.
But the other thing that we have also is you saying, Matthew Lawrence?
Oh yeah, no, I said what AI described is right. We retrofit it to fit our preconceived notion that the Earth is a globe. None of us globers use what we see on the horizon as a proof that the Earth is a certain size because of the refraction and turbulence. So we don't say we shouldn't anyway. It's a specific size based on that. We just sort of backfit based on other reasons.
Yeah, Matt, that's what I was saying about
so
out there actually calculating the atmospheric conditions and then fitting a curve or a model data points. That's not what happened.
Right. So what actually happens is what Matthew said is that just retro-engineer post hoc the observation to fit the pre-assumed assumptions. That's what happens.
I don't believe that. When you guys bring up the black swan or any of these long distance observations, I don't ever believe these to be winners for you guys in the sense that they ever prove the flat Earth. They really just, if anything, they give you a stalemate, but it's really not a stalemate because it's really just refraction. We can prove that.
Yeah, but notice what you said. It's really just
they don't ever prove the flat Earth because the flat Earth does it have a geometric horizon?
Geometric would mean the curve of the Earth, as in, no, it's not a geometric horizon. The flat Earth wouldn't claim that. It's a limitation.
So the flat Earth has an optical horizon, and I wouldn't doubt that either because action is going to be causing objects to appear closer and further away, depending on the day, which is what we see on the supposed flat Earth.
Your globe, in practicality, when it comes to imagery, also has an optical horizon. That's the whole point of why it's in different places all the time and why you have to use refraction to retro-engineer what you're seeing.
We agree that refraction is an actual thing and it can bring things from behind a curve, right?
It depends.
Right? Well, it can. I can demonstrate that.
Really? How are you going to do that?
Oh, I got a video for you.
I said how.
Something. I'm going to do it by demonstrating the air density.
Describe it.
Bring things from behind a curve. That's how.
Okay. Okay. So what's your setup?
I got it for you.
You have a mouth with words, right? You could just tell me.
Well, I prefer you look at it. I mean, why would I just tell you what's going on? Here we go.
Well, because if you don't tell me, then I'm not going to be interested enough to watch it.
Oh, well, it's refraction bringing things from behind a curve, right? That's what it is.
Oh, my goodness.
Spraying some stuff. Bringing things from behind a curve. He brings the light from behind a curve. It's in the chat.
Oh, you mean that one instance where the light or the laser actually bends over, like from one from one direction to another in a single instance, and not that the light is actually continuously curving over its entire trajectory. That one.
The one that I just posted is the video that I'm talking about. Yeah.
Exactly.
So this is done inside. This is done inside somebody's house.
I think so. Yep. That's not the relevant point, though. The relevant point is the fact that when he sprays that can and makes that little particular part more denser, you can see that the object comes from behind the curve. If you want further details,
how long is the video? I don't know, dude. You suck at explaining things. 6 minutes. Holy crap!
Are you like? Do you need like special help in me explaining to you that it's bringing something from behind the curve by the dude spraying? Like, come on, dude. Is that complicated for you? Like, how much of an explanation do you need? It's pretty simple.
Took long enough just to get to that bit. To be fair. You could have said that.
I mean, I said that like 5 times.
No, you didn't, dude.
Didn't say that it brought something back from behind a curve because he changed the.
Watch. I'll give you an example. So,
like, come on, dude.
A fish tank, a bent piece of metal, an object on one side of the metal, sugar solution added to the water. Camera on the other side of the fish tank can then see the object which was previously occluded by the bent piece of metal. Well, that was hard.
Or you can just watch a very simple video, as long as you're
can increase your language skill
IQ individual
and take an example from me and actually be able to be concise with a point and have a good word picture.
Yes.
Are you watching the video?
Yes.
Heck no.
All right then. That's the thing. I'm not talking. I wasn't speaking to you, Jeddah. That's the thing. I knew you weren't going to watch the video. You're just trying to have like a philosophical discussion about something that's.
No, dude. I told you had to get me interested.
Well, I'm sorry that you're not into. I'm not that interested in refraction either, man. It's not that cool.
I posted 2 little videos for you that just debunk what you just said, by the way. But go ahead.
Oh shit. Atmospheric refraction. Well, why don't you name everything else? I think I've seen the original video. Can you bring up the original video from the YouTube? It's always with the shitty camera qualities, man. It's always what it is. Do we have heat waves?
So suffice to say, here we have 2 instances of objects in the distance due to atmospheric conditions being quote unquote bent, the light being quote bent down and quote obstructed by what? A hill, a quote unquote curve, is the curvature of the Earth, or is that just the light bending downwards? Thank you very much.
Well, have you missed? What have you missed in this video, Nick? What else do you think you missed?
I didn't miss anything. I just outlined it perfectly. What more do you want from me?
You outlined everything. You didn't miss anything.
You mean you want me to give you more of my time and energy in the last 48 hours of back and forth and obfuscation on you and Jekyll's side wasn't enough to finally conclude at something so simple that it took about 5-10 minutes of everyone.
Do you think you missed anything else without the monologue? Because I don't think anyone gives a shit about your feelings. Do you think you missed anything else in this video?
You mean so you can monologue over me like a little rat fuck?
Yeah, we're not monologuing. Do you think you missed anything else in this video, Mick?
Like what? Point it out to me. Little rat.
Like tides. You don't realize it's going from high tide to low tide. You don't get that either.
You're a fucking rat.
You know how heat waves affect cameras?
You're a fucking rat.
You don't get that either, right? I'm a rat because you don't know 2 things and you don't know what the fuck is in your video. You think this dude's so stupid, man.
I said you're a fucking rat and you know you are. Go back to school.
I'm a rat? Yeah, dude, sure I am. That's why you don't understand shit. You're getting schooled by a teenager. You can't see. You don't know what tides are. You don't know what tides are, dude. You're stupid.
Yeah, keep thinking that.
It's funny. You're calling me a rat, but I'm actually talking about the subject and you're too busy monologuing and crying of how you were in here for 48 hours. Oh my god.
Yeah, keep at it, man. You're winning, right? You're winning. You're winning. You need to make up terms.
You're a grown-ass man and you're crying.
You need to make up terms and laugh at people to make your point.
Are you mad? I didn't even make up that term, but are you really that mad about the whole Mick fraction thing? It's not my fault you created your own
fraction.
I'm
just fucking frustrated at your stupidity and your arrogance.
Yeah, so I watched the video.
At least I'll be.
Guess what the comment?
I find Mick fraction pretty funny.
At the very
cool
least,
story.
it's funny. I'll give it to you. But at the very least, I'm honest enough. I give the truth.
Hilarious. So I watched your video.
No, you're not. I can prove you're not honest.
Who cares? You want to talk about which one of you is honest? You two can go to a private room and stroke each other till you figure it out. Oh, I watched this video. Guess what the comment is that's left on the video? Did you spray? Because he doesn't tell you.
What?
So it does appear at the end that he demonstrates that these objects were on a board, and the board had a bow in it or a crown, so the board is not completely straight. Did spray some kind of gas that caused the light to be able to be seen from the objects in the back, right? Okay, so we all know light can be redirected. I mean, that's not impossible. So if it's the case that he has an ambient room temperature and then he sprays this thing, which has a different optical density, right? You have the variance between the air and that density. Is there any analogous environmental condition that exists like that on the Earth generally? How would I know? Because he didn't tell me what he sprayed or what the temperatures were.
I don't think that's. I mean, those things I won't say aren't relevant, but I will also say this. I think it's pretty simple, right? He sprayed
That's pretty
something
simple.
that was obviously made that particular area more denser, so that you can see something coming up from behind a curve, deviating from horizontal.
Okay, so let me ask you this question. In a bedroom or in a living room, have density, right? Radiation of pressure. If you introduce a gas, right, very quickly, and so it doesn't have a distributed density. In other words, it's got like a pocket, going to be a very sharp turn, versus when it's distributed in a gradient, and so each gradient layer is kind of more homogeneous. So the more appropriate analog here, because if you think about it, in your worldview, the amount of quote unquote curved gradient that would exist in the length of this board, so minuscule that it's practically a horizontal gradient or horizontal gradations, right, of a vertical gradient. So essentially, you're modeling a near flat Earth with an anomalous temperature bubble. So what's this supposed to be proving again?
No, I'm not gonna lie.
All this is proving is situations, which by the way isn't what's happening all the time on the Earth. But if you need extreme situations to prove this, it seems like that it wouldn't be happening that often. I really don't get what this is supposed to be proving.
Well, I already told you what it's supposed to be proving in very simple terms. That you can bring something back from behind a curve by increasing the air density. And that's what I demonstrated. That's what I claimed. I demonstrated my claim. So that's all good.
Yeah, so if you could show something being redirected out of this scale, in principle, nobody denies the principle, right? It's the application that has to be validated. Think about it this way. So a lot of times you people ask, well, why are the bottoms of things always can't be seen? One could just easily say they could provide an example of refraction driving the light downwards using a fish tank, right? So what?
So that's McFraction, I think, is what you're mentioning right now. Actually, I
don't know. No. Think about it. Have you ever seen the fish tank test where they put a laser on one side and it drives the laser downward as it goes over towards the other side?
Actually, haven't. Can I see that one?
What? You can also do that with. They have gradient index media that have the same thing happen.
Admittedly, I wish I saw that for you ago. Thank you.
Yeah, but I mean, I think what you might be referring to is McFraction. I don't know if it is or not, but
you mean the term that you guys coined up to describe a known phenomena that I just failed to bring up?
But Matt, are you denying? Like, you had your video, right? And then I showed a video to where the same optical phenomenon could happen over a known flat plane in their camera view. Like, why? Like, do you not understand? Like, if this, what you're saying is, oh, this is why at the globe, but then we could demonstrate it while you can recreate it over a flat plane. It's just an optical phenomenon that happens when refraction happens. why do you continue down this road of saying you are correct when you have been then thus debunked? Because it goes against what you're saying.
I've not been
because
debunked.
You're saying it has to be a globe for this optical phenomenon to happen. I just posted a video earlier that shows you're wrong, because you can create that same freaking scenario over a flat floor. Come on, bro. Just be genuine with us, man.
Okay, so
we just want honesty.
Okay, so hold on, top of the monologue. Okay, so your video, you said high tide, low tide, right? I understand that first principle, right?
That one, if you're saying the high tide is now somehow the water is going higher than the cove that it's in, and then it's blocking out the other side of this cove, the houses, the trees, and everything about it. If you're saying that high tide was was producing it, I would say you are wrong, because the high tide didn't go higher than the ground, the high what the tide is in. It's just showing you that optically it raises. You can't say, "Oh, that's just high tide." Really? So the high tide makes the water higher than the houses? Bro, come on.
Yeah. Well,
Okay,
it depends on how low the camera.
we have a few
Depends on how low
things.
the camera is.
Yeah, it also depends on that. We don't know how high the camera is, but it's a few things. So heat waves do affect cameras where it looks like things are bending outwards.
I agree.
So
I agree
like
with that.
that's also a phenomenon. So like when light passing through these layers of like air, it can get bent or refracted, right? So it can cause a distortion of objects viewed through them. This effect is similar to how like light bends when passing through water, right? So like, you ever seen like light passing through water, or like light rays from the sun hitting water, where like things are kind of like looking benty and shit? Basically, like that's what happens with cameras as well, where like heat causes like the air near the ground to become like
So
less
does the
dense than the
cold.
air above it. So
is the cold.
sure, yeah, sure. What I'm saying basically is like heat can affect cameras on this. I don't know if you ever like seen a video where like some dude's recording something in the desert and the heat is so intense that it's like bending things, but that's basically what we're seeing. Plus high tide, low tide. So those two factors included.
Okay. The second video I posted showed
quality. That factor included too.
The second video I posted showed Sky's freeze demonstration over a flat, known level, horizontal, plane, flat, whatever word you want to use. It can show you that what you're explaining to be a globe, but the floor is not a globe. But you have the same optical phenomenon observation of seeing these pieces that are on a flat floor, according to the camera position through perspective. It looks like it's going now lower than the baseboard. That is an optical observation. So all we're doing here, Matt, is explain to you that it doesn't have to be a globe.
No need a monologue, dude. No need a monologue. I get what you're saying. Can I respond?
Okay, good. Go ahead.
Okay, thank you. So, first of all, like, can I get more detail on the second video? Because it's like the water doesn't even look like water. It looks like some
no,
it's
not water. The second video is not water.
What is that?
The second video is these plastic pieces that are on the floor, and I think they're like 30 feet. I forgot. I could post the whole video if you want, but it's a flat.
Post the whole thing, dude. I want to see the whole thing.
Okay. I'll do that. I'll be back. Hold on.
Because I need to see more of it. Because it's like I don't know. A lot of these videos. I don't know if it's just me, guys, but a lot of these videos have like really, really shitty camera quality. We're in the 21st century, and a lot of these videos are really bad quality, man.
I'll give you that. Let's get one thing straight, though, right? So what we've demonstrated so far on both sides of the aisle, right, is that light can bend downwards depending on the conditions in the air and the atmospheric, the indexes of refraction that ensue due to the different variables of the air, right? So if you have a laser light pointing up, let's say at a 20-degree angle, right, behind something, right, as what you brought up demonstrated, it can be bent downwards to, let's say, continue a propagation at, let's say, 10 degrees.
Here's the full video.
Can I, right?
Hold on, here's the full video.
Yeah, thank you. So if we take that same set of conditions, right, but instead of pointing the laser light up at 20 degrees, and we point it down at 0 degrees, right, would it not be fair to assume that that same set of conditions will bend that light down towards the ground even further, and thus actually maybe go into the ground?
No, I know what you're trying to mention with your refraction, but I've never seen it demonstrated, so I can't speak on it. Like I've never seen your type of refraction demonstrated. I mean, I'm surprised that this is something being brought up.
So I'm just bringing it up as because we don't have any more bits of information beyond what we have now. We've got to think about it, right? So this is just one thing I'm putting forth as a reasonable proposition, right? Because if it's light bending down by
either, but let me check this video out.
Yeah, check it out there. But light bending, refracting down by, let's say, 10 degrees or whatever, it's going to refract down 10 degrees no matter what the angle it's going at, right? So if it's going at 20 degrees, it goes down by 10. It continues at 10 versus it's going at 0 and then it bends down. Now it's going at negative 10, right? I.e. into the ground. Is that too far-fetched proposition to consider?
It's a little too far-fetched until I get like a demonstration of it, an actual demonstration of it. Like
fair enough, but fair enough.
We have the ones where you can. So make listen, dude. I'm gonna be honest. When Brenda first came in here, when he came here last time, or maybe the time before last time, where he mentioned it kind of opened my eye a little bit when I was like, well, I mean, how can a light bending or hitting objects bending ever cause an illusion that it's below something that it's not? If we're talking about water, I don't think that's possible, right? But we have demonstrations for what we claim for something being brought up behind a curve. If you can do your own thing where you're showing this MIG fraction, I would love to see it as well. But I mean,
watch the video.
Yeah, let's look at the data behind the video. So this video, hold on, Mick. I want to
go.
This video.
That whole video has all the data for you. She breaks it down, like everything that you need to know, the temperature, everything about it, bro. It breaks it down. Just take a look at that with an honest heart, and then
we're on the video.
Back to us. Go ahead.
Let's check it out there.
We're on the video, so we're gonna have to break this down, okay? All right. So wait, hold on.
But now, keep in mind though. At the same time as we're watching this, consider what AI brought up earlier about the fish tank, right? That would be one instance of what I think I'm talking about.
I haven't seen the fish tank either, so I can't comment on that yet either. Haven't seen the fish tank yet.
Fair
I don't
enough.
actually comment things I can't. So that's the difference.
Fair enough.
I'm still trying to.
But I will say, if you persist to elude ever watching it, you can hold by that stance, and we can never move forward, right?
Well, I haven't been demonstrated it to ever watch it in the first place.
That's fine.
Teaching them about MIG fraction? Are you teaching them about MIG fraction?
Welcome back, Jekyll. That's what we're talking about.
I'm trying to share the screen so it's showing the video that we're all looking at, or the video that was called throughout the chat. But by the way, up front, there's no data here.
Yes, there is.
Let me leave the call.
The whole beginning of it is The whole beginning of the video is everything. They break it down. They show you everything, bro. Come on.
Yeah, Matt, you're cutting out when you share the screen.
There it is. Am I good now?
I don't see it. I hit view stream, but it's just spinning for me.
Review it. I can see it. You guys can see it.
Okay. Maybe it's my end. Maybe I don't know. My internet connection is messed up.
A refresher thing or something. Mick, can you see it?
It's loading for me.
Yeah, it's like continuously loading. It's not showing anything.
Try again. Fuck's sakes.
Yeah. I'm gonna watch stream. Spinning. There it is. Go ahead.
It's the wrong stream.
Shit.
It's the wrong. There it is. You see it now?
Hold on. Spinning. I'll let you know. Wait. You had it
so
earlier.
It's just not gonna. It's just not. Well, it's just not gonna show this screen, is it not? Like, what the fuck?
It just must be. It must
there
be.
It is. Now I see it. Now I see it. Go ahead.
Oh, it's loading for me. Oh, there we go.
At least you can see. At least you guys can both see the study of light refraction. That's just funny. Make fraction it should be, but so we have links to other videos, but in the description.
No, press
first
play
of all,
on the video. Press play on the video I posted. What are you doing?
Okay.
Stop running away. I'm just kidding. Go ahead. Click on my video. There you go.
Going up a bunch of random shit. First of all, no demonstration for proof of anything going on in this video. Shitty camera quality.
It's 7 minutes long, and she tells you at the beginning everything. They show the measuring tape, everything. They show the floor, it's level. They break it down.
Matt, it must be
floor.
It must be the McFraction gods getting in the way of your stream.
Yeah, your stream is all choppy. It might be your connection. Yeah, it's your connection.
One thing also, I'm going to pause the video right here. One thing also that Mez has demonstrated, I need you guys to also acknowledge this, is something called your camera aperture. When you increase your aperture, the aperture of your camera, you can resolve things that you think you can't resolve because cameras have apertures on them. Right?
Yeah.
So another thing, I hope she manipulates that variable because that's something very important. I don't know if Mick, you've seen the Mez video where he demonstrates it, but that's something you need to also account for.
I have not yet.
Just check it out, and we'll go from there.
I'm gonna show you that video as well right after this one.
Show the temperature. She shows you everything.
So Saturday, humidity 64%. That's pretty decent humidity, to be honest.
Would you by any chance be able to full screen?
I can full screen now.
There you go.
This is as good as yeah.
So those are the plastic pieces from the camera's perspective, right? That's the way you see them on the board, on the floorboard. But once they open the door, you'll see they disappear because the refraction kicks in and that temperature literally throws them behind as if they're behind something, but they're not. They're not behind anything. It's an optical phenomenon. Go ahead.
Well, what do you mean? Is she spraying something? Is she changing the air density at all?
Yes, exactly. She opens up the door and then they let cold air come in. They're showing you the properties of what temperature does to an object in the distance.
How do you know she opened up the door?
She says she opens up the door and lets cold air in.
Let's see if she ever says it.
Boom! Right there, right there. She's literally said it.
Mm-hmm. How do we know she hasn't fucked with this? How do we know there's no fucking with this?
Just must be her floor's curving.
There's like half the people in here just.
Oh, actually, because you could. The one thing you could also add on to this or have a factor in this is if we had two cameras, right? If we had two cameras looking at this at the same time, that'd be great.
Here's the problem. Here, you know what? This is the problem, right? If we're always just going to start resorting to on both sides, right? If we're just going to resort to claims of there's potential tampering. That's not anything anyone can ever really verify.
Come on.
I'm just saying, like, it would have been great if, like, let
me finish.
Why? That's so illogical that she wouldn't do that, though. That she wouldn't put two cameras so we can see.
Do you think she has a stake? Do you think she's a flat earther and has a stake in proving to the world that the Earth is flat, or something?
She is a flat earther. Is she not? Is she not a flat earther?
This is, as far as I know, this is just a scientist doing optic experiments.
No, she's explicitly a flat earther. You can go through her comment section. You can go through the description in her video. It's very
So are you discrediting her because her
No, I'm just
position in
giving
it?
context. She is a flat earther.
Okay, that's fair. That's fair.
No,
That's
he's
fine.
giving context. I'm
That's fine. That's
discrediting her. So I think there should have been two cameras so we can at least get the two angles.
That's fair. But that
would
doesn't
further
take away
substantiate
from their
it.
observations. I get it. I agree. You're right. Get two cameras. It is what it is. But the fact is that she's
Also,
showing.
I'm also just mentioning. I would have loved for her to also increase the aperture on this camera. But let's get another better one. Does she have a better one? Or is this one forever?
Yeah. So maybe if you care all that much, maybe
you repost the link.
But why such small objects? Like, why such small? And then there's light here or not light here. Wait, I just noticed something. Also. There's more. You guys see this? There's more light here than there is light right here. Like so when we watch the video, hold on.
Go.
When we watch the video, right?
Hoping, bro.
You saw the objects right here. You can't see, but this is where there's more light. There's less light around here as well. It's also another thing that we have to
You're
Here's the
coping
thing.
right now, brother.
Allow me to say one thing, Matt.
There's
I commend
no coping. There's literally more light there than there's light on the other side.
Look, hear me out, Matt.
And it's sad that we have to do this with such small objects, dude. With the fucking this shit's an inch.
Matt, hear me out.
Coping, brother.
Hear me out. Hang on, Matt. I commend you for your degree of scrutiny. Okay, I think it's worthwhile for you to ask questions. Okay, and that's a good thing. That's not a critique at all. It's a thank you for your service. Let's say. Okay. The point here is that what you guys were asking for has been somewhat, to say the least, substantiated now, right?
No, it hasn't.
Supposedly, let's say. You guys were saying that it didn't exist. You guys said that it's not a phenomena, and I made it up, and all of a sudden it's a new type. Okay, well then you have a point of contention to bring up to this young lady who did the experiment and not us, right? So thank you, Apocryphon, for bringing this up. I had no idea it was a thing.
Yeah, for sure.
Can you post the link again?
I posted it in the chat.
Here, let me get this demonstration out here that was done by one of the GF6 guys. We're gonna look at now. Make and Apocryphon.
But here's the point, though, Matt.
Hold on, no more questions. We're gonna go to this video now. We're gonna check this out.
I'm just gonna. All right. So just for shits and giggles, I'll just mute everyone till I find the link. How about that?
Well, the link is. Let me post a link in the chat.
Thanks.
Yeah. AI has to use it now. AI has to use this shitty camera little too fucking.
No, I just wanted to see it because you're going, and I can't use your screen. You know what I mean?
Yes, you're right. You need your evidence. Anyways, Mick and Apocryphon, check this out. This is some cool stuff as well that you guys have to see. So this is Mez. So all credit to Mez for this video. I posted it. Where these flat earthers have done these coin experiments. Have you guys seen these coin experiments before?
I've heard about them, but I haven't seen it.
Yeah, so these Apocryphon, have you seen them?
Yes.
Yeah, so these coin experiments are basically flat earthers showing, well, things can be obstructed bottom up behind the curved surface or whatnot, right? And Mez has a response to this, and it's actually very simple. So he has a light. Hold on the far end of his desk. You see as he decreases the aperture, right? Light goes away. He increases the aperture, light comes back, decreases the aperture, light goes away. And that's something that flat earthers, I don't think, ever account for in their little coin experiment videos when they're trying to show something bottom up behind a curve.
Okay, now relate that to zooming in on boats. Go ahead.
Zooming in on boats. No, I'm saying this is not a response to the boats. This is a response to the coin flip
So
videos.
relate. Who gives a shit about coins? Relate the coin video.
That's the purpose of this video. It's not about boats.
Okay, so relate the coin video to reality and zooming back in on boats from the waters.
I hate when Timbo just jumps in. He doesn't know what we're talking about, but he just jumps in. Dude, this isn't about fucking boats. This is about bottom up obstruction and Mez's refutation of the videos that people post.
Bottom up obstruction on a table when the camera is below the table. Yeah, that's what you're saying, right?
Yep.
Yeah, so the camera
this camera's above the table. I'm pretty sure it's like an intro
above the table.
Yep, you can see it's above it.
Camera's above it.
So, have you seen the coin? Have you seen the coin flip videos?
Now, but this is what I'm saying. So relate the coin to zooming back in on boats.
Well, this isn't okay. Maybe you're not listening. This is not about boats.
You suck at describing things, right?
This is a refutation of people who make coin videos and be like, this shows that things can disappear bottom up.
Who cares about coins?
That's what the flat earthers make. They make videos where they point a table, they point a coin at the far end of a table.
Matt, you suck. You suck at explaining things, okay? You agree?
I'm a great explainer.
No, you're not. You're horrible.
I'm a great explainer.
Okay, if you're a good explainer and say something concise so that Timbo can actually understand what's going on in the video, go ahead.
Well, the problem is Timbo kind of joins in. And sometimes he doesn't even know what we're talking about, but he just says something. the problem.
Right. That's why a good skill to have would be able to give him a concise
I try to explain it to
presentation.
him, but let me explain it to you again, Timbo. So this video, right? This is Mez's video, GF6 Mez. He is responding to videos made by flat earthers where they show a coin at the far end of the table or maybe a light, and they're like, well, it's obscured bottom up, right?
Okay, cool.
His response is that when you increase the aperture, you can actually bring the light back. Or the f-stop, right? You can see he increases or changes the f-stop, which can also obscure the light. You're going to see it here in a second.
You know what that proves, bud?
There it is. Boom. Light gone.
Yeah, that
light
proves
back.
the point.
See, these are...
It does prove the point.
Yeah,
it does prove the point.
These prove my point. So from now on, that everyone's seen this, flat earthers are now going to have to add this to their videos. If they're ever going to make a video, they're going to have to account for these two things.
Calm down. You just proved that things can disappear from the bottom up due to visual effects, yeah? Due to changes.
So let me ask. Well, hold on. We understand that, bro. When you decrease the aperture size, you've decreased the angular resolution, correct?
Well, sort of, yeah.
Sort of about it. That's literally the equation. Okay.
Yeah, that's what I said.
Rally criterion equation, the aperture is one part of the equation, which when reduced would reduce the angular resolution. So if you can see an object, when he has the large aperture and then you decrease the aperture and the object becomes unresolved, that ipso facto proves lowering the angular resolution disappears the object. Yes or no?
Exactly.
Yeah, yeah, sure. But this is a direct refutation of the coin flip video. So now when everyone like flat earthers make demonstrations...
Oh, dude.
It's not a refutation.
Oh, it actually is, believe it or not. So when flat earthers make videos, they have to account for this now. So that's the thing. They have to do it.
The way you just explained it, it's not a refutation.
Matt,
It is though.
Matt, before you go on, Matt, I just want you to recognize what you said. You just said decreasing angular resolution can cause something to disappear.
Bottom up? Yeah, sure it can. Like a light.
Oh, there you go.
Changing the f-stop. That doesn't prove that that's the reason ships disappear bottom up.
Look, that's fine. I don't care. I don't care.
Because we zoom in, it doesn't resolve it.
Okay, zooming in it. Listen, bro. Simply zooming doesn't necessarily change your angular resolution.
Zooming in it, not increase the aperture? Or increasing the aperture doesn't bring it back?
Oh, the aperture increases the aperture.
All right, then, beautiful. So if we increase the aperture and it doesn't come back, then what?
It depends on the relationship angularly at that distance. Okay. It's not as simple as just increase the aperture.
Yeah, anyway,
for example,
it's
the angular relationship, right? The further something is away, it's going to have different angles than something close up, right?
Of course. But anyway, all this video is supposed to demonstrate now is that when any flat earther here posts a light video or a coin disappearing bottom up, they now have to account for both of these variables and they have to manipulate these variables with the aperture and stuff. So if they don't do that, then we're not going to accept the video.
The transverse is also true, is it not?
Now you're on about the transverse.
Yeah, so all of the Glober claims need to be done through the same scrutiny in reverse, correct?
Oh, sure, we can do that. Of course, when we're doing but we don't. But the thing is, we don't demonstrate those videos with the coins and stuff. So, really,
no, you just demonstrate things that are at such a range that you can't validate any of the optical phenomena that's going on, and just use an ex post hoc mathematical formula to just say, "Oh, it must have been this refraction." You gobbledygook.
I mean, if you're that dedicated and you think that angular resolution is the real problem or it's perspective or something like that, I would suggest you get a really powerful camera, whatever is more powerful than a P1000, and you can zoom in to the Chicago skyline, zoom in to a boat out, and try your best to bring it back. That's my.
Have you ever done that, Matt?
Personally, no, absolutely not.
Oh no. Think about it this way, Matt. What if, purely hypothetical, already agreed that a decrease in angular resolution could cause something to disappear. And you have ambient optical effects of the atmosphere as well, right? So what if all those things combined make the available light at the bottom of something not be able to reach the optic in the end? What if I make an elegant mathematical formula and draw a bunch of squiggly lines on a piece of paper in orthographic projection? About that?
Your best,
Well,
and let's review it.
Do you have
What?
that mathematical formula that you're talking about? Because we can go through the mathematical formulas of refraction and thin lens equations, and I can explain to you how those all make sense, everywhere, right? You could
Everywhere.
Everywhere, man.
Yeah,
Everywhere. Lenses are everywhere. They're floating in the air.
Well, I mean, so thin lenses are the equations for thin lenses.
Dude, we're not talking about lenses, dude.
Okay,
Thanks.
I know we're not talking about lenses.
The original argument. Hold on. The original argument was that he produced a video and said, "This is why it's a globe." Yada yada yada. And then we produced a video that showed the floor that's not a globe, and it produced the same results.
Yeah, I know. I
So-
saw that video. You're talking about a video of a person taking.
Wasn't even his claim.
I know, but you're taking photos of objects that are less than a millimeter high, right? So those aren't really accurate representations of what we're talking about. And
what is an accurate representation? What is an accurate representation?
Well,
Same size.
A board on a table saw, and then you introduce a gas over the board. That's more appropriate.
I don't know what you're talking about or referring to. Are you referring to a particular thing?
Dude, I could care less, dude. It's about the principle. If it's the case, somebody does a demonstration where they have a board and they introduce a gas that's hyper-cooled or something, have an object on the other end of the board. The board's... I'm positing a hypothetical, right? That's why I said if. Okay?
Okay.
Can you engage in a hypothetical?
No, I just don't know what you're referring to. You seem to be referring to a specific thing that I'm not aware of. So I'm just making sure we're on the same page.
Okay, it's Alpha Bravo Tango Charlie Zulu 45897ZZ 3XB exclamation point hashtag 214798. Okay, go look it up.
What?
Go look it up.
Okay.
Well, I mean, you wanted the specific rather than just hear me explain it. So now you have the specific. Go look it up.
I didn't ask for a specific. I just was trying to get on the same page as you. I don't know why you're really going down this childish road of.
Well, it's option A. You listen to me explain it, or option B. You go look it up. Which one do you want to do?
Okay. Well, you're talking about a board, and then you put pressurized gas around that board.
Yep.
Go ahead.
Yeah, so I messed up in the beginning because I forgot to say the board has a warp to it. So it has a curve, right? So he arranges the board that it lays to curve up. Puts objects on the one end of the board. He puts the camera on the other end of the board.
Sure.
Then he sprays it with an aerosol of an unknown compound because he doesn't explain what it is in the video. So it's some type of gas, obviously. Transparent gas. It looks clear. You can't see no color. And either by changing the density or the temperature, which is unknown because he doesn't say what it is. In this presentation, once he introduces the aerosol spray and see a differential in the objects that are now being able to see more of behind the apex of the board, right? So in other words, Homeboy was using this to describe, I can show you, quote unquote, refraction showing me more of an object that's over a curve, right? Now, transversely, the other guy says, okay, I can show you a flat surface doing something similar. So why is the height of the object matter?
Well, so when you're talking about a flat plane and you're talking about index of refraction, that light rays change their angle. If you have a very small object sitting on that plane, and you have a very low camera angle, like the video that we were talking about earlier, the issue is that can be highly exaggerated in that instance. So you're talking about, so like if you're talking about like a 1 degree index of refraction and a change in temperature, you're talking about a few degrees. So if you're talking about incredibly small objects that can be hidden or kind of shown out in those situations, you're talking about very, very small, like you have to get everything precisely right and all the like temperature has to
I gotcha. Yeah. You have to get everything precisely right just to prove a principle. When transversely, when the guy had the board, it's just, oh, everything's hunky dory here. That proves the point.
Again, I don't know what you're referring to. Like, again, you're.
Yeah,
I
look,
just have.
it's not for your look. It's not for you.
I guess
and the other people who are here can understand your scrutiny applies to both.
But you're talking about somebody spraying a board in like with an aerosol and then being okay. I guess that makes sense because they're changing the index of refraction and being able to see like beyond that curve. Sure.
Right. So then, okay, yeah. So see, this is exactly my point, dude. Exactly my point is when I tell you about the board and I tell you about that, you're just like, sure. But when the other guy has a thing with a flat surface, it's like, oh, exact angles. I need to know the precision.
Well, okay. So when I was, thank you, Mick, for linking that video. So the video that I was talking about, the issue with that video is that she is incredibly low to the ground. She's using objects that are incredibly small, and she is using imprecise measurements of temperature and fluctuating between those rapidly. So all of those things.
How do you fluctuate? How do you fluctuate between measurements of temperature rapidly?
Well, so what she was doing is she was just wantonly opening doors and letting cold air in, right?
So
that's.
So what?
Okay, well, so that's.
Yeah, so what? No, yeah, so like the other guy was just wantonly. The other guy was just wantonly spraying. The other guy was just wantonly spraying an aerosol.
Again, you're referring to this video that I've never seen before.
I linked the other one.
Yeah, I saw it. I'll watch it. I'll watch it in a minute. But so I just want to like the issue is that you're saying, oh, well, these principles don't make any sense or are untrue if you watch this video. It's like, no, she just did a bad job of explaining why these principles exist or like why they matter.
What are you talking about? Her goal wasn't to explain, her goal was to demonstrate.
Yeah, Bird, I think I would appreciate, and I think other people in the room would also second me on, is if you apply this, take a few minutes and go check out the other video and apply the same degree of scrutiny that you're applying to this first one to the other one, and then maybe we can
good luck.
Little show and tell and compare. Yeah, I know, that's why I'm asking it.
Okay, but they're both like YouTube videos that's like
exactly
people are making.
Yeah, so in a way,
I'm not using this as like I know that Matt was using this as evidence, but I'm not using this as evidence, right?
I know, but you see our point, right? Or the point being made.
Well, why not? It can be used as evidence. Depends on the proposition you're using it for, correct?
I mean, if you're using it as evidence that somebody made a video in their apartment, then yes, but I don't think that's
no.
Like,
how about evidence that optical results can be affected by ambient conditions in the atmosphere between point A and point B? How about that?
I mean, we've always known that. Everybody would agree with that.
Right. And then on top of that, one person's doing it over a flat surface, one person's doing it over a curved surface.
So the difference and I have seen the video. The difference is that the scale at that the video that Matt posted is over a much shorter distance than the distance that the ladies' videos are talking about.
That hurts your argument, by the way.
No, it doesn't. So the distances are shorter over that curved surface, and the objects are much bigger in his version. Again, I just scanned through the video a couple seconds ago. I don't think it's a very good video either, right? I think that it is getting across what they're talking about, but it's not really great at.
I feel like you're. Go ahead.
I would submit to the audience that the analog of scale is actually more appropriate if you're trying to talk about things in the distance, right? When it comes to a flat Earth type argument about things that occur in the distance, than having things very big close up.
So if you're using small objects over a large distance, like the woman in the video was, that is more reticent to exaggeration by atmospheric conditions. That's the issue that I'm coming at. Again, it's not a very
Don't you get that if you're scaling it against the quote unquote curve that's so flat you can't tell it's curved, right? It's more analogous in her example than it is in the board example.
Okay, but so what I'm saying is that there's too much variables. There's too much variables that she didn't account for. She's just showing a video.
She's not accounting for variables, dude. For goodness sake.
I know, that's the issue. She's not accounting for variables.
Here's the thing, Bird. The only point of these videos is to demonstrate that the phenomena exists, and not to make the claim that over 1 foot it should curve this many or bend this many degrees. That's not the point, right? This topic of discussion has been going on for several hours after I proposed I didn't propose the video, but I proposed the phenomena as a possibility to explain a video or an image that we saw, right? And I was dogpiled and ridiculed for even proposing the idea, right? So much so that it was dubbed a new phenomena in my name, right? And I reintroduced the topic tonight to get other perspectives on the matter, and Apocryphon brought up the video that we're looking at to demonstrate that, oh shit, surprise, surprise, somebody has done the experiment or the observation to actually demonstrate it's a known thing, right? So this is where we're at. It's just about acknowledging that the phenomena exist, period.
What the phenomenon is that you're talking about.
I just don't want you, Bird, to miss the forest of the trees. Like you're not understanding that the whole point of it was, in comparison, if you can take a board that is warped and curved and then introduce a gas and then make it
I don't know why
visible.
you keep referring to this video. Like I agree that it's a bad video.
Okay, so but the point though is that,
goodness, he's trying, dude, listen, bro, lawyer. Let him finish what he's saying, thanks. Okay. It's getting annoying with you keep bringing up that it's a bad video. He's trying to make a point.
Like
I care less. I'm still talking. Okay, so I could solve this problem real quick. There you go. All right, go ahead and speak, Apocryphon. When you're done and you want Bird Lawyer to be unmuted, you let me know.
Okay, sounds good. The whole point, Bird, is that if Matt introduced a video and says, this is why we know it's a globe, it's a curve, because we can see something on the other side of a curved a board, and it's going to raise it up through this optical phenomenon. Okay, that's his claim. But then I posted a video that shows the opposite, to where you can, over a plane Earth, and you introduce refraction, it now lowers it behind the said curve of the Earth in your paradigm that you believe in. But we know that board is not curved. We just know that optically there's a phenomenon happening, and it's making things in the distance, which is why I said that destroys your argument, because you're saying, oh, because it's so far away, now that somehow is not a good thing. But on the contrary, It's a better thing because you're seeing over distance. When you introduce this change in temperature, it creates optically this phenomenon that those objects are now behind the said curvature in your paradigm. But we know that that's not curving. Go ahead, Bird.
Okay, so there's a lot of things that are issues here. So Matt was correct when he was talking about apertures and how light, because a camera collecting light to display an image is not collecting from a single point. So if you have a larger aperture, you're going to be letting in more light, which means if you have something near the surface of something, the light rays that are hitting the surface near the camera lens and then hitting up and coming back into the camera lens are going to block other rays that might have gone through had that surface not been there. So when you're talking about incredibly small objects, ones that are less than a millimeter high, and you're talking about an incredibly far distance, like the distance at which she was looking at those objects and the objects themselves were over 1,000 times the distance of the objects. Those are going to incredibly skew your data and how you're looking at things.
That's well said. That's well said. Perfectly said. Yeah.
Okay, fair. But I will like to point out that what you said was that if you have a limited amount of angles and you have light coming in that's overblaring other light, you're going to lose parts of the light because you have smaller aperture. Correct?
No, a larger aperture will do this. A smaller aperture lets less light in and will actually it will cut down on blurriness in images.
Okay.
So you think that this phenomenon that we're seeing optically, you're saying that the aperture of the camera on over a flat board is going to mimic the same thing as a curved board? Is that what you're saying? Because that's what we're seeing, right? That's the proof, right?
Okay. So,
but in the same argument, go ahead.
Okay, so when you have a camera, right? A camera does not collect from a single point. You're basically collecting from a large collection of sensors, right? I don't know how big modern cameras are. They're probably a lot smaller than like old time cameras are. But if you think of like a film reel, right? The entire like that like square that you're talking about of the film reel, that is everything that's collecting the light.
Okay.
So when you're okay, go ahead. Sorry.
So with that being said, if the same optical observations can be produced over two different surfaces with two conditions that are obviously a phenomenon, when they result to the same effect, how are you trying to throw in apertures making it on the flat board?
I'll tell you. Very simple. It's called the economy of scale. So if you make a scale and you assume a point source, right? For example, like he said, an aperture and a sensor actually occupy physical space, right? So if you do a certain type of scaled observation, it would be equivalent to making the observation in reality with a camera that's 100 feet tall. Since we don't have cameras that are 100 feet tall, and we can't actually make an equivalent observation. So you have to take into account angles of propagation, angles of reception, the angular resolution, the sensor size, all of these different factors, right?
But surely we'll make an AI technology that will sort that instantly.
I don't know why people...
Maybe. That would actually be a worthwhile endeavor.
I don't know why people just say that.
Before you go on, Bert, I want to say one more thing to Homeboy. So You know when they do this, you remember this, they take the P900 and they put it off center of a basketball and then they zoom in on a basketball. You remember that, Apollo?
I don't.
The classic meme that used to exist. Now,
where they
shoot that scale.
Yeah, I remember that.
Yeah, but the problem, the problem with that scale is that if you're going to equivalent that to the Earth, you would need a camera the size of a continent.
So you're telling me these 1 mile shots that people are having, the bullet always goes straight?
What?
Dude,
I'm
I'm going to give you one chance. Hey, listen, I'm going to give you one chance to get on topic, and then I'm just going to mute you for being drunk.
Oh, apologies. Do you want me to leave?
No, I just want you to be on topic.
I thought we were. Sorry.
We were talking about cameras.
And by the way, AI, that's a great point. Like this basketball over a camera, you're right. Like, look how big that lens is over a basketball. It would literally have to be like the size of a continent. That's a great point. Like, you cannot compare that because that's like apples to oranges, right?
I do think
it's the same thing.
It's a pretty good meme.
Oh, honestly.
Go ahead. No, I was just saying it was a funny meme. Go ahead.
Another meme, by the way, which says Ober's doing science, and it has that image of them zooming in on a basketball, and then the next image says flat earthers doing tests, and it shows them shooting a laser 25 miles over a body of water.
What was the end result?
The end result was that the target, which was only 2 meters off the ground, received a laser 25 miles away.
Must have been McFraction.
Must have been. This is known as the FE Core laser test at Lake Idsil, which was the longest one they did in that series. They did like 17 shots, culminating in the final shot, which was 25 miles, which they panned it horizontally through 2 different targets at, I think, 8 and 16 miles. Proved, that the laser was on the same plane. And it hit the target. They received an image of the beam centroid at that range at approximately 2 meters, 6 feet off the ground. Nullifies the globe geometry by 2 orders of magnitude. However, of course, without fail, the globers claim, well, light just curved around the ball, right? The catch-all salvation device.
I don't know what that is.
However, they then go on to say that we know how refraction works, yada, yada, yada. So someone please just, give me the model of refraction in the ambient atmosphere that we can use to actually do a laser test via laser transit methodology and get a benchmark and a differential of the surface to the laser. We can just, measure the Earth once and for all.
I mean, you would have to have extreme temperatures for that to occur, right? You'd have to have you'd basically have to be, what is it, like every few miles you would have to curve the laser like 2 degrees. So if you want to destroy the entire atmosphere by burning it all off, maybe.
Well, all of the crude oil that we put into the air, that could combust at any time. Apparently, we've only got 1% left of our shield around the Earth.
Talking about the ozone?
Yeah.
Oh no, we repaired that hole. You didn't hear about that?
I don't want to get kicked. So.
Yeah, repairing the ozone hole. We stopped the ozone hole from happening.
Yes, it was actually accomplished by introducing a chemical into Taco Bell that upon eating, after you fart, it floats up and fixes the ozone.
I like that. But it's half true. I mean, the amount of cattle that we have in the world, you imagine. But again, I don't want to take you off topic. I'm sorry.
Yeah, but just note for the people that have been paying attention for the past 4 hours that there were two primary concessions on the table: that the arrangement of the angular relationship and the aperture and the light conditions to cause things to disappear, and also the reduction in angular resolution can cause things to disappear. So
that's
progress.
Stealth, though. Yeah, that's stealth, isn't it?
And there was an official Australian here to witness it. That means we covered it top to bottom and bottom to top simultaneously.
Yeah, how you doing upside down, man? Are you okay? You good? Just making sure.
You feeling sick yet? Upside down. Too much blood in your head. Maybe that's why you're so smart.
Probably.
So McFraction proof, I guess.
Correct. Well, let's cause it. Well, look, phenomena definitely occurs, as demonstrated. Whether it's analogous to anything in practicable reality at different scales, that's a different story. That remains to be
yeah, and that's fine.
Associated.
The only reason why I brought it up was, again, a highly speculative, pie in the sky idea or supposition as to why something was happening. Didn't make any claim as if it was exactly what was going on, right? So I think the key takeaway from that is basically if this phenomena can occur on either, let's say it can be used to suggest either sides are correct, it's effective to, at least at this point, maybe nullify that argument from the conversation and then move on to other points.
Yeah, Mick, you remember the fish tank with the gradient laser going through it after they fill it with sugar? They put it at the top of the left side of the fish tank, and then it redirects and it has like a, it's not a perfect arc, but it's kind of like arcing downward. It almost looks like a ballistic trajectory, right?
Is it the one that you mentioned earlier? I hadn't seen it yet.
What? Man, it's been going around forever, man. Good grief.
You got it?
Anyway. I was looking for it, but I couldn't find it.
No, it's okay.
So the majority of ones that you get when you Google it are using multiple. They're not showing this effect. What they're showing is a laser bouncing, like in straight lines. So it bounces off this side, bounces to that side, then bounces out, hits something. So they're just doing like straight line direction versus the gradient direction.
A form of internal reflection type of thing.
Yeah, but what's interesting about the fish tank example is that you essentially have a rectangle with a flat bottom. You fill it with water, and then you put sugar in it, which creates a density gradient that is essentially horizontal, right? And so you essentially have, at that scale, a horizontal gradient, a flat bottom, and curved light. So if anything, that's demonstrating that with a horizontal gradient atmosphere and a flat reference level, you could have curved light. So it's like, it doesn't even make no sense, dude.
Yeah. This good point.
At scale, you can't get a scaled curvilinear gradient. The only way to get a scaled curvilinear gradient at all is to use a solid medium. You can't use liquid or gas medium at that scale.
I mean, if you brought that up with Scott Mackey, he'd probably argue, "Oh, there's a 45 nanometer to it, but we can't tell." Right? Like
that's not an equivalent. It's not an equivalent scale. That's the problem.
I paused for you. Yeah. The joke is, he says that bathtub, right? You know that one? Do you know that argument?
The bathtub, the Sagata in the bathtub makes it so he can't see his toes.
Yeah, apparently it's 45 nanometers, right? According to the calculation.
Where's the math for that?
I hadn't seen it, but apparently he did the math, right? And according to the standard model, right? If we assume 4959, right? And we're getting the curvature that we do, right? You scale that down to whatever, 6 feet by 4 feet or something like that. Across that 6 feet, it should be 45 nanometers. I mean, okay, like, prove it, I guess, you know? But yeah, so yesterday, I think my point in this was really like, okay, like I was saying before, is at this point, you know, if this phenomena is known and to be used on both sides of the argument, it's effectively null and void because people will bicker on the details, and time might be better spent trying to scrutinize specific points that are individual to the position, right? And that's why it was brought up. Okay, we'll just prove the curve, just measure it. You know, like that's the one distinct. I would imagine the one distinguishing factor in the argument, but for some reason it seems to be continuously evaded, and I wonder why.
So Earth is just a two-dimensional surface now, or is it a 3D object?
Why would you ask such a question?
I'm wondering, how do you start to steelman flat Earth if there is a definitive case for the model? Is it a two-dimensional surface that is just infinite, or are we on a three-dimensional object?
Okay, so all objects that exist in a tangible sense are three-dimensional, categorically.
Okay, so 3D
flat, right? So flat, in the context of planar, where all points are coplanar, right, doesn't exist in three-dimensional space. So, for example, objects that are defined as flat, that exist, that we can use, are defined as flat in a tolerance scale where all the points are between two parallel planes. So in other words, there's a tolerance of scale, right? So when somebody says flat in tangible reality, they don't mean ideal. For example, if you took, just for sake of argument, 197 million square miles, which is what is claimed for the Earth's surface territory, and you took the oceans being 2/3 of that, but let's just use 150 million to make it simple. And you took the high tide, low tide from the mean sea level, which has much less than 100-meter swing. You took 100 meters over 150 million meters square, and you variance that into a flatness scale, you would find that that thing is exquisitely flat. If you then add the depth of the Marianas Trench and the height of Everest and the differential there, which is a swing of 13 miles, you would still have an object that is functionally and practicably flat. if you did a mean line between two parallel planes of that scale. So, yes, it could be described as flat, and it's a sufficient description. Unless, of course, it's a ball, then it couldn't be described as flat. It would have to be described as smooth. So, I will give you a mulligan that was a sincere question, but it's actually, all things being equal, a ridiculous question.
I don't think you answered my question.
Okay, so I'm gonna give you one chance to reflect on what I said. Yep. So bye. Goodbye. You're done here. Thank you for playing. You lose. And anybody intelligent have something to say? Imagine thinking and asking if the Earth is two-dimensional and be taken seriously. Imagine that. He belongs over at the Bev server, not here.
That was really stupid. I was wondering, I was about to ask him, but I was going to interrupt. I was like, where are you going? Where do you think you're going with this?
I mean, he ought to maybe take that question out to whatever official fucking global cosmology servers exist and ask that same question, because isn't there a claim that, my universe is actually flat? Or something like that.
The problem is, as well, that guy that asked the question claimed and used to be a flat earther.
Yeah.
Oh, I remember that. And he said that shadow from the moon on Venus or something like that is what turned him into a globe earther.
Mm-hmm. He used to debate on another channel for flat Earth.
Oh my goodness. So he's asking in the chat, I'm asking, what does flat Earth even mean? It could mean anything at this point in time. So, for example, flat could mean kumquat, for all we know.
I mean, wait, he used to be a flat earther, but he doesn't know what flat Earth means? What?
Correct.
Yeah. He's confused if we mean it's a two-dimensional object. After I explained to him that two-dimensional objects don't exist.
To make the statement that I once was a flat earther is an odd comment to make in the first place.
It's not that odd.
Matt, with the video that I posted, do you at least understand why we question it? Can you at least come to that line of like
I've watched your video. I've watched your video. I mean, if we're gonna keep talking, I don't even want to keep talking about it, but what I will tell you is this: it's that obviously the objects were not up to scale compared to my video. My video refraction was clear. Your video, the objects were really small, and the way cameras work with light, just like the other, what was his name? Bird was saying. Obviously, the bottom is going to be less visible regardless. Okay, sure. You can say I didn't get it. Whatever you want to say.
Right. So Matt, you made two concessions today. You gave two examples of how, one with the Mez video and one with the Sky Free video, and conceded the point that optical effects, regardless of the parsing of the particulars, but the category of optical effects can and does disappear the bottom of things. Well, thank you.
That's not a concession. That's a fact.
Okay.
That's something that can't happen, and especially with small objects like light. Yeah, when you have a light and you manipulate stuff like that,
that's a concession, dude.
That's not nothing new. That's nothing new. That's not a concession. Anything.
Listen,
and if you knew what that video was actually meant to do, it was a direct refutation to any flat earther that makes a claim that they can show bottom up obstruction on a table with a
Oh my
coin.
goodness,
That's
dude.
directly what that video was meant to do. And it
AI,
did do that. It refutes the flat earther that
Oh, wait.
makes that claim.
AI, I dare
does.
you. AI, I'm sorry. I dare you to try and continue that for another day and a half. Try it.
Oh my goodness. What, you mean talk this topic for a day and a half straight?
With this guy specifically.
I mean, look, I
What,
don't
am
need
I
him
not
to
am I
agree.
not indoctrinatable enough to you or something?
Oh, dude, it's just that look, whether you agree to the particulars the way I phrase it or not is irrelevant. It was demonstrated on 2 occasions that you admitted this particular situation that occurred, even though you scrutinized it, is a case where the bottoms of the things can't be seen. So kudos.
It directly refutes all your flat earthers that try to prove it as well, just so you know. So as long as you understand
Prove
that, then you're
what?
fine.
Prove what though? Prove what?
The flat earthers that prove, oh, you're talking about bottom up obstruction. I can show it with my table and a coin. And then they make that dumb video, and then Mez makes a video where he's like, well, manipulate all these other factors and do it because I can bring a light back just by zooming in with the aperture. Yeah, so that's also another
but did he?
But if you were to
did he
put it up
do
to
it on
scale,
But Matt, did he do it on a flat surface or not?
Yep, he did actually.
But that's not the point. The whole point of bringing the light back means that it wasn't there to begin with, means there was a condition that existed at a moment in time where the light wasn't available to be seen, meaning it was disappeared.
Okay.
So the very point itself proves the point, dude. Proves that there are conditions that are not the presence of a physical obstruction that can cause the bottom of an object to be unresolved in the final image.
It's a possibility.
You're proving out.
The thing is, you
Right.
see, it's in a. Hold on, Timbo. I'm gonna let you go after this. The only difference is
You're gonna
right,
let
is
me go.
what we.
Okay. See how that works out for you.
I was just gonna finish my point, if that's fine. Can I not finish my point?
Go ahead, man.
So the difference is AI Overlord from what we have at sea or what we have in this controlled environment, where the flat earthers do the coin experiment, okay, in a controlled environment. Maz did the light experiment, just like the flat earthers can do the light experiment in a controlled environment where we can manipulate all the factors. We know that the table is perfectly flat. We know where the light's orientation is. We know all these factors. At sea, all we know is that the water is supposedly horizontally flat, and we zoom in with like P1000s. Those are some things that we can't manipulate all the factors of. We can't just like, get up and just check all the water out, right? If we did that, we'd, see that there shouldn't be anything obstructing it, depending on how high we go, right?
Doesn't make sense.
That doesn't make sense.
If your argument is things can disappear from the bottom up due to other things apart from curvature, you're arguing our point.
Yeah, it's like you don't understand it yet. I don't know if it's like something that's not clicking. When those flat earthers made the coin experiment video, they're trying to show.
This is another. Yeah. Okay. Go ahead. Yeah. Sorry. Go ahead.
Yeah. So when the flat earthers make the coin experiment video, I just want to make this clear to you. When the flat earthers make the coin experiment video, they're trying to show that things can appear bottom up on a flat horizontal surface. What Mez is trying to portray is he's like, zoom in on the aperture, increase the aperture, change the f-stop, manipulate these variables to your viewers because you can actually bring the light back. And it's not a matter of it actually being obstructed, but it's a matter of you manipulating your camera. Now, when you use that factor out at sea, you can do that as well.
Can you just 1 second? Can we just go back to the table? Is his camera in a position where is it level with the table? Like what are we saying?
Yeah, I would say so. It's above the table by like at least an inch or two.
You can't say I would say so. You're explaining his.
It's 2 inches above.
So it's 2 inches above the table. So get this, Matt. It's above the table, yet the coin disappears on a flat surface. Yeah?
Yeah.
And then he can bring it back into view. And I'm the one that
And the
doesn't
difference
get it?
with that video is I get it. I get what you're trying to say. And the difference with that video
I'm
is
not trying to say
right?
it. That's what you're saying.
Yeah, no, I
All
get it.
he's trying to do in that video is mislead. Let's be brutally honest.
Anyways, the difference with that video is, Timbo, is that that light is not gradually disappearing bottom up, or it's not ever bottom up in the first place. It's either you can resolve the light or you can't. So you can't make it an argument for the boats either.
Yeah, Matt. But you're
And if you
saying
want to
things
manipulate these variables, anyone can do it. Anyone with a powerful enough camera can try to
you're
go
making
ahead
an
and do it
argument,
as well.
dude. You're making an argument coming out the two sides of your mouth. On one hand, you say that
Yeah,
it's being
exactly.
obstructed, and on the other hand, it's okay that it's obstructed. It's like, dude, you're gonna come to the realization that you're arguing for our point. Like, there's no two
Yeah,
ways about
exactly.
it. That's
Yeah,
just what you
it's
have to
well.
do.
If you want to think it's for your point in one way, you can. But this is also a direct
Matt,
refutation to the other
1
flat
second,
earthers that
man.
do the coin experiment videos.
You do
I don't
this,
know
you
what-
just keep on going. But
Yeah.
what the point is the camera is above the table, yet the coin can disappear and come back into view. You're arguing our point.
Yeah, that's what we're saying. That's exactly what
Okay.
we're saying. And whether or not
And
Mez likes it-
addressed this like a million times, so I don't know why it's still confused by
but
anybody
why
here.
are you getting flustered?
You're the
bro?
only one that's confused.
Listen,
Well,
listen.
it's not
we're-
that I'm getting frustrated. It's like that I
Yeah, you are.
explained. Okay, I explained one thing as well.
I can hear it in
you
your
being
voice,
able to
man.
resolve the camera.
I can hear it in your voice. You're getting frustrated, bro.
Okay, you being able to resolve this camera. It's never. I mean, not resolve the camera. Resolve the camera. Resolve the light. And it's not about bottom up obstruction. There's never bottom up obstruction about it, right? It's just being able to resolve it. Yes, you're bringing it back on a flat surface, but when we're looking at objects far out, we zoom in. We never bring it back behind anything. Never, ever. That's another thing. So you can never do it at sea, but of course you can do it with the light, and the light's never being bottom up.
Yeah, but hold on, dude. Like,
Sorry. Wait.
You're breaking up, Timbo.
What?
Timbo,
You're breaking up.
What are you
You're breaking
saying?
up. You're breaking
Wait,
up,
what are you
Timbo.
saying? Yeah, go ahead. Sorry.
I say
Yeah.
I said when we have objects far enough out, we can't bring it back in the sense of bringing it below the bottom up obstruction by zooming in.
Have you tried?
What?
We've seen the video. I've seen a video of it.
No.
Video
I'm
of
not
the
talking
guy
about
trying to-
seeing a video, dude. Like,
Holy crap!
all you're doing
I tried
right
it
now-
personally.
Yeah, listen. You're standing on an affirmative right now because you think that somebody showed you a video, and using this video, you're catapulting yourself into a fallacy. So you don't think that you're doing that
there's
right
no
now,
fallacy included in this.
Yes, there is. You're actually appealing to
What's
this
a fallacy?
video. Have you scrutinized this video with any rigor, any type of rigor?
Which video? Which video?
The one you're questioning or mentioning right now that you're saying, well,
Oh, when we're
there's a
talking about the
video.
Mez video?
I don't know, whatever video you're appealing
well,
to.
listen,
There's a
listen,
method-
guys,
Oh yeah, the
guys.
Mez
There's
video.
a
I've
method
watched
by
it a
which
million
was-
times. Yeah.
Yeah, there's a method by which that was done in that video, and you're seeing something happen, right? Yeah,
The problem is the specific problem here in this example is that scale of zooming in versus the aperture is much different at short range than long range. Zooming in doesn't change the necessary size of the aperture by much when it's at a far range, comparatively when it's at a close range. So there's no expectation that if you increase the distance of your What one are lens you from the other talking lens. about?
dude, stop talking and interrupting when he's giving an explanation, will you?
That was no explanation. He was just speaking words.
Yeah, to you because you don't
Speaking
understand
words here.
shit, dude.
You could just go on mute and listen. There you go. Speaking words, dude. Okay. If you want to know what I'm talking about, what you do is you say, "Excuse me, could you clarify that in like a simpler way?" Something like that, dude.
Yeah, he's trying to give you an uppercut while he could.
And when you zoom in on something, okay, with a telephoto lens or a zooming apparatus, the lens increases the distance from the other lens and the focal plane, right? They separate from each other. Some cameras might separate 3 inches or 5 inches or 10 inches. Oh, a 10-inch differential between the two lenses is a much different scale when you're talking about looking at a coin over your table than it is when you're talking about looking at something 30 miles away. So in one instance, 10 inches could represent a seventh of the entire table. So a factor of 7. Whereas at 30 miles, right? It's like, well, 30 miles times 5,000, 3 times 150,000 divided by your 8-foot table. See the difference in scale now? Not that hard to understand. So hopefully that was simple enough so that Renee could understand it.
Well, I want to see if Matt understood what you said in order for the.
Well, hold on. Let's see if Renee understood it, because hopefully that was simple enough. All right, go ahead, Renee. Let us know.
No, you just go ahead and continue to speak words.
Yeah, see, he's not gonna. He's trying to throw an uppercut. AI. That's all he's doing. He doesn't.
I don't know what he's doing. It's like he gets bitchy with a globe earther speak. He get bitchy with a flat earther speak. It's like he's just on bitch mode tonight for some reason.
Yeah, what's crazy is. Hold on, APOC. But have Scott Mackey come in here and he'll be groveling before his feet. Outside of that,
think about it this way. 10 inches out of 100 inches, 1/10, right? 10 inches out of 1,000,000 inches is a different fraction, correct?
Of course it is.
All right.
What
so
would
now
you
that,
say this is though?
Wait. Hold on, Matt. I wanted to get to the point that now that AI has clarified the difference, the method that was actually done. Because like you're throwing your body into this whole argument, you're putting all your chips in and saying I'm all in. You don't even know the method by which AI was describing to you the difference between scale. Do you understand?
You're telling me I don't understand scale? What the fuck?
Yeah, the scale at which the aperture is being used for the camera that they're using. The table versus the long distance of 30 miles, or watching something like a ship disappear bottom up.
We were not talking about 30 miles. We're talking about 12 miles.
It doesn't matter. The scale. Listen, the scale is the most important thing. So the distance to the ship.
Beautiful. We can do the math. Let's do the math.
Right, wait a minute. You're talking about doing the math, but you don't. Do you understand scale? Like the quarter that's on the table or whatever.
Dude, I'm a globe earther. You don't understand scale because you think that the Earth is small, dude. Like,
I don't understand scale. Yet he explained it to you how it is.
When you talk about locally flat.
Matt, no,
when you talk about things being locally flat, you're not the one that understands scale.
That's not a part of the argument. Right now, you're trying to figure out why the bottom-up obstruction is taking place. You said on the one hand, the flat earthers have a point, right? That there's something happening. Yes or no?
I don't think they have a point at sea.
Dude,
I think they have a point only in the videos that they've already been refuted for.
Stop being obtuse. Is something happening in the video where the flat earthers showing something with the quarter? Yes or no?
Well, that's been refuted by the Mez video.
I don't give a shit, dude. Answer the question. Is something happening?
If you didn't watch the Mez video, then you don't understand the coin video's refutation.
Matt. You're not answering the question.
They don't have a point. No, they don't, because they never increased or decreased the aperture.
No. I'm not asking if something, a point. I'm asking, did something happen when the video was shot and they were watching a quarter move off into the horizon of the table? What happens?
Yep.
Answer the question.
The aperture was not increased. That's what happened.
No, dude, why you gotta be such a weasel about it? You see how when you want to
weasel, the aperture wasn't fucking increased, and Mez demonstrated it.
You're presenting evidence like you know what you're talking about. Yet when you see the video of the quarter, you get all shriveled up and you don't want to answer.
Holy
why?
Shit.
Why?
Dude,
why?
Video of the quarter is not even what's in contention. You don't even realize that. We were talking about the Mez video.
Okay, no, I don't give a shit. Man. Right now we'll talk about Mez video, but we want to know why you don't want to answer the question. Answer the question why you see the quarter disappearing on the video that the flat earthers presenting. Answer.
Because the aperture wasn't able to resolve it.
The aperture is not able to resolve it? So
you have to increase it. Yeah.
So what do you see happening?
What do you mean, what do I see happening? The aperture not being able to resolve the bottom of the coin. That's what I said.
Thank you. So that's what you see happening in the video, right?
And then you increase the aperture and then you can see it. There we go.
It doesn't matter. Though what you're doing right now is you're using the difference in scale does matter. So that's what AI was pointing out.
I agree with you, and we agree.
Oh, all right. So now you're understanding the difference, right?
Scale? Yeah, I think we all agree on scale. That scale is important. Yeah, of
all
course
right.
it is.
So if something's happening because the aperture, like you said, once you increased it at the short distance scale, right, and it shows that the bottom up obstruction is happening due to the fact that something was increased, which was
the aperture.
Okay. So basically all it was the aperture increasing, which means it has something to do with optics. Yes or no?
Of course. Yep.
Okay. So we're dealing with optics. We're not dealing with actual obstruction, like the table's getting in the way, because that's not what's happening. Everybody understands that, right? The physical table's not getting in the way of the quarter. You know that.
And just I agree with you on that point. And just for some background information, the Mez video demonstrated he had a light at the end of like a far end table, and what he was saying was that flat earthers weren't manipulating variables like increasing the aperture, because basically when he increased the aperture, he brought the light back.
So. Yeah, he's making an addendum. We don't give a shit about his extra points that he wants to bring in. That's not our argument. He's doing another argument. That's not what we did, okay? That's not what we're doing. In any of the videos that we're showing...
That's a direct refutation, though.
Yeah, you know, the direct refutation is a straw man. It's trying to beat up something we didn't say. You can laugh all you want. It's the truth.
But would you say that if someone's trying to prove something, Alpha, right, but they didn't manipulate something, they would show them that they're wrong? That would be a problem? Because what the coin video is demonstrating.
Yeah, in context though, you have to do it within the context of what the person's doing. Not do another test about use something else. You have to actually directly use what they're doing and then show what they're doing wrong in what they're doing. Not exactly something.
He did. He did.
No, he didn't, dude. Because every single person that can do this, all you have to do is listen. What I'm gonna tell you. Everybody that wants to do this, all they have to do is lower the eye line straight down to the floor, and you decrease the angle of view. So when you're decreasing the angle, things in the far distance are going to start to blend in. You're going to see this happening. It happens like all the time. If you get your eyeballs down to the ground, most of the things that you see in the distance are going to start blending in because you're decreasing the altitude or the elevation, excuse me. The elevation starts to decrease, and then you start to see less and less of the distance. This is obvious, dude. That's because you're decreasing your elevation. Not because, listen, it's not because of what you're thinking that it's going around a curve. There's like, you could take something like
Alpha.
Your flat floor can do this. Is what I'm trying to tell you.
No, I know what you're talking about, but I'm just saying, if you didn't watch the Mez video, then you don't understand why it's a refutation.
Listen, if Mez is trying to make another argument, I don't care about that video. That's not what we're saying.
It's not another argument, dude. It's directly on the argument, dude.
And directly what we're saying has everything to do with decreasing the angle of view. And how you can't see something in the far distance.
That's what he did. What he did was he had a light on the far end of a table, right? And his camera was 2 inches. The camera lens, I think, was 2 inches above the desk or the table. Yeah. And he couldn't see the light, right? But then he increased the aperture. He brought the light back. He decreased it. The light was gone.
Bro, listen, other people because see, when flat earthers do something, they give you a method by which you could do something too. Have you done this? What the flat earthers done?
Or anything like experiment done?
Yes.
I haven't done anything.
Then go and do it because you're speaking out of your ass right now, and you think that Mez is you think he's better than sliced bread at the moment, but you haven't done anything to actually prove whether or not Mez or any of the flat earthers are saying something correct. You're just blowing smoke up everybody's ass right now, and you want to just get away with it.
Mez demonstrated it clearly.
We don't
it doesn't need to be repeated.
Yes, it does. That's the whole point. When somebody does something and you're just taking it on faith or that they've done it correctly.
I didn't though.
Yes, you are. You're in here arguing for
okay, if someone manipulates all the variables and shows you everything, how
do you know?
Is it still full of shit?
No, how do you know?
I've seen the video. You haven't even seen the video.
How do you know he's went through all the methods and all the steps? How do you know that?
all the relevant methods and steps were in the video, and I've seen it. Dude,
I'm asking specifically how you know that. How do you know that?
Because I've watched the video.
No. I'm asking, have you
did it in the video, like he decreased it, increased it, everything in the video.
Have you accounted for all the variables that need to be accounted for a distance of 12 miles?
12 miles. That's not about the video. So I don't think so, no.
So the video is speaking about something else, just like flat earthers are. We're not talking about the 12 miles that's in contention at the moment from seeing a ship disappear from the bottom up. We're talking about what's happening optically and something that can disappear without having an obstruction of something physical, which is what you think that Mez is showing.
Would you agree to this too? Would you agree with this too? Is when we're doing things with light on a far end of a table and we're bringing it back with increasing the aperture. First of all, that's a refutation to the flat earthers with the coin things. They never increase or decrease the aperture.
Lying,
they never
bro.
do that. That's first
Stop
thing.
lying.
Am I lying? They never do that.
Look, Matt, get off your high horse, dude. You're not the all intellect person. And I only think that you're smart enough to get this, but you're so far up that Globe Earth's butt that you don't see your own like cognitive dissonance, bro. This is what's happening to you. You're turning into a weasel like the rest of these characters because you're hanging around their dumbass. I already told you, you do have a mind capable of understanding shit, but what's happening is that you're dipping too far into the level that they're in right now. They're too far gone, man. These guys like Mez and everybody else. You at least are trying to seek truth to some extent. But what you're doing right now is a dirty weasel tactic, and you know it. You know it, dude. That's why I'm upset right now because you think that you're doing justice to the globe. You don't even know what you're talking about.
Bro,
I asked
listen,
you,
dude.
bro. No, hold up, dude. I've asked you for all the variables that were included, and you don't know any of the variables. You said Mez is just.
Well, I can name you the variables. Can I name you the variables right now?
Go ahead. See if you cover them all.
Okay.
Go.
Seeing the table, seeing the position of the light, increasing the aperture, decreasing the aperture, resolving the light when you increase the aperture, not being able to resolve it when you decrease the aperture, changing the f-stock, right? When you change the f-stock and you increase the f-stock, actually, you can make the light also disappear just by increasing and decreasing the f-stock on a flat table. There you go. All the variables. I miss anything?
Yeah.
What did I miss?
I can't believe that's all you got.
Well, that's what's in the video. That's basically what it's trying to demonstrate. Is basically
So
that like increasing the aperture.
Yeah, he gave you confirmation bias that the Earth is a globe, and you took it hook, line, and sinker because
No,
you're not going to
that's not
question
proof that
any
the Earth is.
farther.
Wait, Alpha. That's not proof that the Earth is a globe, dude. That's not.
Oh
So
yeah,
all
To
that
you,
was trying to.
It's confirmation bias, bro. Because you want to
No,
prove
it's not. Okay, listen.
Yes, it is. You want to prove the flat earthers wrong, and so all you're doing right now is throwing a lot of stuff in front of the way of truth. So right now, you're just taking whatever Mez is saying as the gospel. You're taking whatever he's saying.
No.
That's absolutely true. Mez did everything he could possibly. Yeah. Did you include the angle of view? Did you?
What do you mean the angle of view? Like 2 inches above the table?
Yeah. You didn't include that, did you? And what you just said, you did not include that.
Wait, I didn't say that the angle. If I didn't, then that's my bad.
Well, hold on,
Yeah.
dude.
He was above the desk. He was above the table.
I got
Is it always the same distance? Was it always the same distance, 2 inches, or did he do different distances?
I don't think he changed the distance at all.
Okay, that would be interesting to do. Like, get a higher angle and then a lower angle, or even
Can you post the video? Sorry,
a continuous
Oh, yeah,
angle
I
would
got
be
you.
cool,
Post in the
so that
chat.
you can actually witness it. Any changes happen as you're decreasing the angle.
It's in the chat. Actually, a beautiful video. Beautiful video, I must say.
Oh, let me click on it. Is it toast?
Anyways, AI, back to your philosophy. I know you got a lot of things to philosophize about, right? Right, AI?
What about it?
I remember you were telling me about, possibility of God not being ultimately powerful, and maybe Satan can take him over, possibly, or something like that. Remember that?
Oh, well, that's a hypothetical.
Maybe we're God. There's so many possibilities out here.
Well, I mean, not really.
That's the thing. That's the big issue, AI. I mean to cut you off, but I'm saying like that's the big issue is that like we can never know for certain. Not knowing for certain can maybe lead you to think that you can get away with something that you can't get away with, and that can lead to like issues.
So,
Mm-hmm.
so I just watched the video, right? So, what are you claiming he proved?
Okay. So, well, I'm pretty sure it's in the video, but the video is basically trying to prove that flat earthers that do the coin experiment are not zooming in or increasing the aperture or manipulating other variables with the camera that can resolve back what they thought was bottom up obstructed. So that's basically it.
But when you zoom in, it changes the aperture.
Well, he's increasing the aperture, which is bringing back the light source, and
But
he also manipulated the F-fog and stuff like that.
Yeah, so this is about a close object. Yeah.
I think
the little LED light. But so what's this relating to about what's in relation to just the coin thing?
Well, it's not just a coin thing. Also, there's a what is it? I don't know if you've seen it. Have you seen the light in the hallway experiment thing, or not experiment, but demonstration?
But I'm just trying to find out what he's like. What do you think he's debunked?
So what he's debunked is that when people make the videos where they have a coin or they have a light on the far end of a hallway, and they say that it's obstructed bottom up, is that they aren't increasing the aperture that could just bring it back. And he showed you that increasing the aperture or changing the f-stock can bring it back. That's all he's trying to demonstrate. That's what it proves.
Well, that doesn't relate to the floor, though, because the floor is a bigger distance. So what he's just demonstrated is that when he increases the aperture, the size of what's going into the camera increases. Therefore, it takes that size above the desk. Yeah, and then you can see the light. Yeah.
In the coin videos, have the guys ever done that? Have they ever increased or decreased the aperture?
When you zoom in, it increases the aperture.
Yeah, sure. Have the guys ever done that in the video? Have they ever done that?
When you zoom in, it increases automatically the aperture.
Sure. Can you post a video of the coin thing again so I can look at it?
What do you mean? Do you know that when you zoom in, it increases the aperture?
No, I know. I'm just checking whether or not they zoomed in and out and everything like that.
So have you watched it? Do you know if they zoom? Because what you're essentially saying is, okay,
I watched it.
Okay, you watched it. So did they zoom in?
I watched it, but I forget a little bit of it. But as far as I'm concerned, they didn't really zoom in that much or anything. If you can post it again, I can check it out.
Because the whole thing that you're talking about is zooming in from when you see bottom-up obstruction. So obviously they zoom in, because that's the whole argument that you're arguing about.
Post a coin video again. I have to remind myself.
I don't give a fuck about coin videos. That's what I was saying before. Like this is what I'm saying about what are you
the video. Well, the purpose of the video is to refute the coin experiment.
But what's that in relation to the Earth?
Okay. Okay, let me try to break this down for you, Tempo. So
we have bottom-up obstruction at sea. You don't need to break.
No, I'm trying to explain you the It's like you don't understand the context.
What is the coin? Stop talking. What is this in relation to the Earth?
Bottom-up obstruction. But this whole mess thing comes from the flat earthers, because the flat earthers make a video showing, hey, we have bottom-up obstruction on the table. Mez comes along and says, no, you don't. Decrease the aperture. That's what it's doing.
Dude, okay, I'm going to ask you a question, and just give me short answers. Don't go off on a tangent, right? When people take long distance photography observations, right? Are they above the surface?
Yes. Hello. Yes.
They're above the surface. Okay. In Mez's video, he is in line with the table. So when he zooms out, the eye of the camera closes, and therefore you can't resolve what's behind the table.
Why do you think that is?
When you increase the aperture, it widens the lens. So essentially what you see is above the table, yeah? So when you're talking about long distance observations, that doesn't happen because you're always above the surface. So it's not.
Isn't the black swan like 1 feet, or no? Is it like 1 feet above?
Yes, 1 foot. It's above it, is it not? By 1 foot.
Yes, but if Mez's lens or camera lens is never above the table, then he can never resolve the. Why you guys gotta pretend
on this like?
How's that?
Sorry, mate. We're having a conversation. Yeah, go ahead, Matt.
Yeah, but what I was saying, Timbo, is that we both agreed that if his camera lens was not above the table, he would not ever be able to.
No, he shows it. It's in line. You said it was 2 inches above. It's in line with it, so it's level. The center of the lens is level with the table.
See it again.
I don't know where you got 2 inches from.
I thought he said it was 2 inches above.
I don't even think you watched it.
No, I definitely watched it. I've watched it like 10 times. But look at that. Look, you wouldn't say that's above the table?
Where?
Camera lens. You don't think it's above the table?
Where?
Just a little bit.
Where am I looking?
In what I posted in the chat.
How can you see it from that angle?
Let me get a better angle. Does it say 2 inches in the video? He says 2 inches.
No, not all.
Not but here's
he doesn't give any heights.
Right, but I mean, basically, what is this conceding that at a low altitude?
It's a better angle.
At a low altitude with less resolving power, you can't see something.
Exactly. Yeah. That's just what he proved.
But this isn't supposed to refute you guys on the sea, really. It's supposed to refute the guys that make the claims that, we have it on the coin and the table. That's all he's trying to do. That's all it is.
Well, but what about it? What about it? Is it refuting?
What do you mean it doesn't?
I don't think you understand it, do you, Matt? What he's actually done.
For example,
I've literally
chill for a second, Matt. Chill for a second. Chill out. So, for example, if you show a demonstration of A happening under A circumstance, and somebody else shows A not happening under B circumstance, then have they refuted the other guy? No. They've just shown a different circumstance.
Well, it's not just different circumstance, right? We have a table, we have a camera. This guy's saying, I can't resolve this bottom-up obstruction. He's like, open your aperture, right? Open your aperture. And the guy's not opening his aperture, therefore he can't resolve it. The other guy's opening his aperture, therefore he can resolve it. The other guy just didn't account for other variables, while the other guy did. So what it's showing is the obstruction.
That doesn't negate. That doesn't.
It's not.
It doesn't.
Come on, yeah.
Dude, it doesn't negate the fact that under the conditions that were present in the initial observation, the bottom of something was unresolved because of optical reasons, not because of necessary geometric obstruction, okay?
we agree. On the table that's flat, we agree that there's no fucking Earth curvature there, right? But Mez's point, Mez is not even fighting us, or he's fighting the people that are on the sea. He's not fighting the guy that's taking the picture of the Chicago skylines. Mez is fighting the people who are trying to make the coin experiments happen as an explanation for what happens in the sea in the Chicago skyline. That's what he's doing. He's fighting the people to do the coin table thing. That's all he's doing, and he's proved this point by telling them to manipulate more variables. That's it. Now, I'm hoping that no one's confused at this point.
Can I ask you a question? Why are we even bothering to talk about this table coin thing in the context of what we were talking about before?
It's not even relevant. I mean, they've just been stuck on it. I don't know.
So it's just brought up ad hoc for no reason?
No, it was brought up for the people that have done the experiments, or not experiments, but the observations.
It's not about table. What it's about is
and the
there's competing. That's fine. There's competing interpretations about what's going on at a distance, or the horizon, etc. People make small scale demonstrations to try to mimic the things. People scrutinize it. Say, well, it doesn't really apply, even though the phenomena is happening here, it doesn't apply to the grander phenomena in the world for these reasons: scale, different conditions, et cetera, et cetera, et cetera. So it's not unreasonable to scrutinize the small scale things or to present them either.
I would say that we reasonably, relatively agree. I mean, it's just Maz refuting the other coin table guys, and he's showing a coin table, or not a coin table, but a light table demonstration. So, I mean, I think we'll leave it at that. It's not even super relevant to what we're actually seeing at sea anyways, but it's just his refutation of the other people that think they can replicate the bottom-up structure. That's it.
Yeah, so how much did the angular resolution change? How much did the angle of incident on the focal plane change? No, I don't want you to answer. I just want you to think about it. How much did they change scale, and what would be the equivalent scale to something on the horizon? Because unless those are known, and right, let's say you took the same. Let's take you took the same camera out to a greater distance. Would the variance of the zoom in or the variance of changing the f-stop have a significant change at 20 miles versus 20 inches? Because those are orders of magnitude differential in factor, right?
Yeah, 100%. I agree with you on that point. 100%. Obviously, if you were to bring it at sea, it'd be a completely different. We'd be looking at a more massive object that we're resolving. I think it'd be easier for him to resolve that object as well. But I think changing the f-stop might change some things as well. I mean, we'd have to see it, but yeah, it'd be different situation for sure. But his demonstration is not to talk or prove the horizon in any sort of way. It's just to refute the other flat earthers that do the table thing. So it's table versus table. That's basically what it is. And Mez is just
no, it isn't. No, it isn't, dude. No, it isn't. Because you said yourself that his whole point, if he's refuting anything, he was refuting the interpretation of the flat Earth table coin as an explanation for why things disappear past the horizon. For goodness sakes.
You can say that, sure. And then we can go
dude,
test
that's
it.
No. You said it has nothing to do with it. I'm just saying that's the only reason it has anything to do with anything. That's the only reason he did it.
The reason he did it was to refute the people that made the coin experiment videos. That's why he did it, right? And the coin experiment people are trying
You're wrong, Matt.
Matt,
I'm trying to help you. So you can speak clearly when you speak. No, you're not necessarily wrong. You're just saying something wrong and then correcting it in your next phrase. So it's like you're incapable of making one phrase that's coherent.
What am I saying that's wrong? Specifically.
You're saying that he's debunking coin video.
But that's not what he's attempting to debunk. No, oh my goodness.
No,
Matt,
okay.
Matt,
Yeah, you've made a critical.
I'm trying to
explain.
Matt, you made a critical error by thinking I'm going to tolerate you interrupting me.
Go ahead.
Yeah. Now, are you just saying he's debunking the coin videos? It's false if that's all there is to it. You must go on to give a caveat or a qualifier because coin videos are just a demonstration of what happens when the camera is in a particular set of conditions. What he might be debunking at all, if anything, is the claims that are associated with the demonstration of what the camera is doing. The camera is doing what it's doing. That's just what it is. So you might be meaning to say he's debunking people who are using this coin video as an analog for what's occurring at the horizon. Now notice how I was able to string that together in a single sentence.
All right. So the one thing that you were wrong about is you were saying that he's not trying to debunk the coin people. But if you didn't watch the video, I'm pretty sure you did watch it by now, is that the video starts off with him literally showing the videos of the coin people, and he's like, yeah, they're wrong. I'm going to show you why. So you are also wrong.
Wrong. Okay, stop. Matt. Think about what you're saying. He showed the coin video. And he quote-unquote debunked the coin video. In order to debunk the quote-unquote coin video, he would have to demonstrate that the effect that is in the coin video cannot be achieved with a camera, a table, and a coin. Now, he didn't do that.
Proving a negative that can't be shown. He's showing that it's not happening due to that.
Exactly.
Yeah. Cool story,
that's
dude.
The whole illustration. So he is debunking it.
Okay, one more time for the slow kids, okay? Pay attention. See if you can follow this. Okay? If it's the case that a camera is placed in a particular location, if it's the case that a table is placed in a particular location, and if it's the case that a coin is placed in a particular location, and the camera with a specific set of settings records something and somebody shows you that video, the only way to quote-unquote debunk the video itself is to prove that the arrangement of things is impossible to produce the image that was produced. That is not at all what Mez did, at all. What he is attempting to say is that this effect is not analogous to the horizon, for goodness sakes.
What do you mean, the horizon? A horizon at a table? On Overlord, what are you talking about at this point, dude? Listen, what Mez did, right, was he showed
you've lost the fucking plot, man. You've lost the plot.
They're just getting muted, dude. I'm done explaining it for freaking stone cold retards.
Yeah.
Okay, I'm going to say this one last time, uninterrupted. Whoever interrupts me just gets banned for 7 days. It's the way I'm going to roll. Okay. If I take a video of my cat, my camera, and it's literally my cat in front of the camera, you tell me I'm going to debunk that video, how are you going to debunk it? You're going to have to prove that that wasn't my cat, or that I wasn't there, or that the camera can't actually film a cat in that manner. Now, if I told you that because I filmed my cat, that means that my cat, the Queen of Sheba, you try to debunk the fact that my cat is the Queen of Sheba. You're not debunking the fact that I took a photo of my cat with my camera, for goodness sakes. I don't know why this is so complicated. It's like such a cognitive bias for some reason to just simply understand he's not refuting anything about what happened in the video itself. Understand that, for goodness sakes? Somebody took an image with a camera at a particular height, at a particular distance from the table. They zoomed in, they zoomed out. They got a certain effect. That's what happened. Now, it may be the case that you're arguing that that effect doesn't account for things we see in other parts of reality that someone was trying to use them to explain, but it's not the case. By showing a different setup, you're debunking that setup. The setup is what it is. You would have to prove that the guy's camera was in the wrong location, the coin was not where it was, and that the table was not what it was. That would be the only way to quote-unquote debunk the video. Goodness sakes, dude, I don't know why this is so complicated. Now, I'm going to unmute Matt, since he's at least redeemable in some sense, and keep AK on mute since he's a lost cause.
I'm sure Matt's redeemable at this point in the last couple of weeks.
Let's see if he finally comprehends that he didn't debunk the video itself. I mean, unless he's claiming that this guy proved it was a fake video, that's not what he was attempting to say. So go ahead, Matt. Redeem yourself.
Oh my God, man. Listen, dude. I don't even know if we should continue, Overlord, because I don't think you're getting the point.
Okay, I'll do it then.
Yeah. You're clearly too dumb, dude. You're clearly too dumb.
Matt, okay. Mez does exactly the same as what the flat earthers do in the coin video, but it's not with a coin. But the only thing he does is explains why it happens. That's it.
All right, so since Matt's a lost cause on that topic, we're going to unmute him for a new topic.
All right.
That way there'll be animosity. We can all move forward. All right, Matt.
By the way, I won on that topic, everybody. But yeah, let's move on.
Nice try.
I had to make sure it was known.
Yeah, whatever,
you're an arrogant bastard.
Gotta make sure it was known, man. Odd with the AI pictures, man, dude. Come on.
I'd say, Matt, like, what do you think Mez was implying? Nah,
come on, don't even. And it's funny because if I was actually given the time, I'd actually.
We're not going to talk about the video, but what he's done is he's tried to put it in relation to the Earth. Correct or not?
No, Tim. Oh, you guys have it so wrong. Let's just move on, man.
Dude, we're not going to go into it, but he says at the start of the video, he says, "I'm going to show you why flat earthers are wrong."
Yeah.
That's it. Oh. Yeah. So let's move on.
Flat earthers, as in the group of people, not as in the Earth.
Okay.
Yeah.
All right. We're going to move on now.
Yes.
This is ending up like the moon with 6 and 9.
Oh, man. Great moon. Great moon.
Oh my goodness.
So, what does zooming?
He literally says the point at the end of the video. I mean, I'm ashamed. I'm ashamed of you, Matt. I thought you were at level 3.
Ashamed of you, AI.
I've put you back. I've put you back to level 2.7.
Oh fuck! What level was that at before, by the way?
That's generous.
3.
You
only went down 0.3.
What's the highest level?
Not that bad.
What's the highest level though?
The highest level is blue, clearly.
Like what?
Don't worry about it.
What's the average level?
Won't be
What's the average level
for a while?
The average level is Spin Bar Keat. Don't look it up.
I've lowered your level by about 1.0 after that.
Matt, so zooming in on boats, right? Can you relate what Mez was doing to zooming in on boats?
You can relate it. I'm not gonna say it's I'm not going to say it's exactly analogous. I mean, there's relations, right? Zooming in.
What Mez proved in that video, can you relate that to zooming in?
I can sort of relate it, but I wouldn't like to specifically, because his video is not meant for that.
Okay, so you can relate it, but you're not going to. That's fine.
Yeah. It's just his video is not for that, so.
Just to show the audience, Matt does not want to enter into that conversation because Mez's video does not prove anything about reality of zooming in on boats.
Well, it's not for boats; it's for the coin flip guys. So I don't know what that's supposed to mean, but well, I mean, AK. We can unmute AK if he wants to talk as well. I don't know if AK wants to talk. He's still muted, so he got muted kind of off
that thing anymore. All right, talk about a new topic, for goodness sakes.
Yes, what's the new topic? What new topic are we going to bring in?
I don't know. Ask AK. You volunteered him to be unmuted, so it's your job.
AK, what's your best globe evidence, dude?
I say if we mute
my fellow globe soldier.
If we unmute AK, then we mute Matt. It's trade for trade.
Come on, man. I'm not debating. I gotta go to prison for someone to be unlocked.
Anyway, Matt, do you want me to help you?
Yes.
Okay, but you got to be quiet the entire time. Promise it'll be short. No, that's not what I tell all the girls. So
what?
Matt, the proper argument. The proper argument from the video. Pay attention and you'll learn. If you want to use this video as an argument, is if you're using it to attempt to quote unquote debunk the coin argument. So the way the coin argument would go is that you're above a flat surface and the aperture and angular relationship, right, can cause something to disappear from the bottom up or angular resolution, whatever. Okay, so there's no physical obstruction, okay? Mez was attempting to say in his video is the reason you can't see the bottom of the object or you can't resolve the object at all in the case of the light is that the aperture is actually below the plane of the table. When you can't see it, it's below the plane of the table. When you zoom in, it increases the size of the aperture, which then makes a portion of the aperture above the plane of the table. Therefore, it was actually physical obstruction the entire time. It wasn't purely optical. It was actually, in one instance, line of sight was directly obstructed by the physical table.
You're still talking about it, man. I followed it, though.
Okay, so that's the actual argument if you want to make an argument out of this video.
Cool. AK can't talk because apparently he's not undisturbed.
Oh, he finally got a girlfriend? Good for him.
What about you? You have a girlfriend?
Me?
You might be married. I forgot. You're pretty old.
Man, well, I'm 40. Let me see. What year is it? 2024. So I'm 44.
Doesn't he know?
I was born in 1980. So that means the first two digits and the last two digits of the year that I'm in added together equal my age. Also, it means I got to enjoy a world to which technology was novel and interesting and revolutionary, exciting. Versus now where everything's blasé.
How was that world like?
It's pretty crazy, man, I'll tell you.
You have Riz back then?
Yeah, dude. I'm 6'3" with blonde hair and blue eyes. I could literally just stand still and I have Riz. The point I'm trying to make there is like, you know how people nowadays play pixel games on purpose, where they purposely buy them to like enjoy the retro feel? That was my life, you know, growing up with those pixels. And then when the new pixels came out, the new graphics, it was like a huge leap forward, and it was a revolutionary experience. People like you really can't experience that unless you were isolated from it, you know. But if you grew up in a general population, like, graphical jumps just aren't the same, and other types of technology too. The leaps and bounds just aren't there anymore.
Yeah. It's just the consequence of advancing in technology, I guess.
Ow.
What do you think about, you know, your name is AI. What do you think about AI? I mean, some guy was using it to fake a video of a principal, or the guy was athletic director, and he faked a video of a principal making racial regards or racial slurs and stuff like that.
Yeah,
and then he posted it online.
I think that anyone who does anything like that when it's found out, they should receive the punishment that the other person would have received.
Ooh. I actually like that idea.
I also think that mothers should be punished for the bad things that their children do. Others.
That's a very deep thing. But that's the
I think
problem
it would force. I think it would force people to take raising their kids seriously.
I agree with that.
It would force women to take choosing an appropriate partner seriously, or to not have children.
I think someone can make a counter argument, but I would kind of agree with that.
I have something to add to that. You know, when a child is misbehaving in public, they always look towards the mother. Like, this is your child. What are you going to do about this? So, I mean, you don't look at the child only, and then, you know, you look at the parents usually.
Yep. What I'm saying is, I mean, you can't even watch a video of whatever a celebrity says nowadays without questioning whether or not it's real, because AI is, you know, replication of people's voices is so good now, where you don't even know who the fuck said it.
Joe Rogan, you know, like all the fake Joe Rogan clips where it's just Joe Rogan commenting about some random cut-in clips with an AI voice.
Yeah, I've actually done it too. I've actually like said things in Joe Rogan's voice with AI, and it's like, dude. I've seen other videos where I like click on it, right? And this is the first time it actually happened to me. I click on it, and I thought Joe Rogan was actually talking about this. And then I clicked on the comments, and they're like, AI is getting crazy. I'm like, what the fuck? This is AI? I'm like, oh shit, man, it's a wrap now.
I wouldn't be surprised. Yeah. I wouldn't be surprised, and it probably has already happened, but it hasn't happened to me. People are going to start having memories of shows that Joe Rogan had. Really was just an semblance of clips that were AI, that were never actually a whole show, but they're going to imprint those memories over shows and actually believe that they watched the show.
And there's also like AI music. We have rappers who have been dead for years, but their voices have been replicated to a point where we're having music being released, like AI music being released.
Yeah. But you know what? You know what's a great way to. You know what's a great way to get rid of all of that from being impactful at all is just enjoy your life with live music. Enjoy your life with real people. Then you don't have to worry about all of that. So, for example, take your girlfriend, or actual girlfriend, that you can pinch and hug and kiss, to a live event, eat a steak, kick your feet back, put your arm around her, right? And the both of you watch the show and enjoy each other, and you don't get on social media the entire time. You don't watch any videos. Everything you watch is in real life.
Such a good idea. And I'm one of those people who I do like going to see shows, but I like to be the performer at the show. So if you can play an instrument or do something for an audience, start getting your stage fright under control and get up there and do the thing.
Yeah, so Matt, so for example, you might decide to date a girl, right? She brings her phone with her everywhere, and the entire time you're with her, she just wants to record the occurrence. So she's recording the stage, she's recording what you eat, she's taking pictures of you and her. And so what you do, Matt, is you take her phone and you chuck it against the nearest brick wall until it smashes into pieces. And then when she says, "What the heck did you do that for?" you pick her up, you pin her against the brick wall, and you kiss her into submission. That's my goal. I say you should do, Matt.
Don't do that.
You're wild, Matt.
Do not do that, Matt.
Matt.
I wasn't planning on it. Trust me.
Listen, Matt. Don't listen to women about women's advice on how to get a relationship with a woman. Women have no idea how to do it.
It's also true. That is also true. Yeah, you're right. You're also
Matt,
right.
I gave my advice to a man who was having a troubled time with his woman, who his woman would never be serious about the relationship, and he couldn't put his finger on what was wrong. I told him to do something like that. He did it. The next day he came back and said, "That was the smartest thing I ever did in my life." Now they're married.
That's interesting. What's going on with paraplegic?
Think about it, Matt. Think about it.
Yeah, I mean. No, that's actually a very it's like it's kind of like a movie like
Think about it.
You know what I mean?
You think a woman? You sound like you're snoring and sleeping.
Yeah.
Matt, what I'm trying to tell you is, a woman actually wants a man who actually wants to actually have a real interaction with her. If you allow her to demonstrate all these superficial interactions in front of you, and you're not demonstrating that you're anything more than a spectator of her being a spectator of the event. So by destroying the frame that she's created about the spectator, you become real. You come out of the fantasy of spectation and you become real. In that moment, she's with a real man. And let me tell you, Matt, he's probably never been in the presence of a real man before. Every man she's ever dealt with has been a spectator, and you are the first man that has ever showed up. Think about that power.
No, I mean, I get what you're saying. No, for sure. It makes sense, yeah.
Instead of destroying her phone, just put her phone somewhere where she can't have access to it. Okay.
Don't destroy it.
Damage someone's property.
Destroy it. Now listen, Matt, if you want to be slick, you can slide her phone into your back pocket for a dummy phone that you strategically bought to look similar to hers to prove your point.
Ooh.
And then after you kiss her, you pull her phone out and show it to her over to the side. She starts to reach for it. You put it back in your back pocket and you say, "There'll be plenty of time for this phone later, babe. What matters now is you and me."
I'm not gonna lie. Okay, although AI is kind of going wild here, that's actually.
Yes, now psychologically, Matt, it is super romantic. You know what else it is? It's a high-low spike. Women love high-low spikes. They love the fear and the rush and the adrenaline, and then they love you being in control. In that moment, you're examining to her that you, in a chaotic situation, you're in charge.
Ooh, I see what you're doing now. Yeah, I see it. It makes sense. No, 100%. You're right. Yeah, I get it. The AI does have Riz after all, then.
Yeah, and Matt just got dating advice from a flat earther, so we all win.
You can always learn from an older man.
I'd recommend just not bothering with any woman that's addicted to her phone in the first place.
That's also a good one too. Yeah. Again, yeah, that's the woman I've never went for. Is the women who are loud or, obnoxious to begin with, right?
There's a problem with that, though, Matt. Explain. If you find a woman that seems to have all her ducks in a row, then how are you going to demonstrate that your presence is what's straightening out her ducks? In other words, friend, women like men that are more powerful and can control the situation to an expected result. And if they're already at that stage, you might not be able to create that dynamic. It's a nuance. It's a catch-22, though. You can do the same thing. You can do the same thing with other types of. It doesn't have to be specifically a phone. It's just a phone is just an easy target because that's what so many women do.
Well, I'd say your main problem with a woman with a phone is if she has all of these social medias. That's usually what keeps women addicted to their phone. From my own experience, I guess, observation. I don't know. I'm the only one that I know that doesn't have any social media. So, and I haven't since high school. So, and I'm 32 now.
It's cool.
Yeah, and a good way to.
Me too, Flatsy.
Yeah, and I'll third that.
32, Timbo.
Me too. Yeah, I don't have any social media.
Yeah,
you know I'm older than that.
I said that you're yeah.
Yeah, and a good way to lead the way for that is to actually do it yourself. Now, I, for example, I deleted my Facebook, my LinkedIn, like years and years ago, right? And I never looked back since. Now, this is actually probably the first social media, quote unquote, that I actually engage with, right, with you guys. But it is anonymous, pseudonymous, if you will, right? I don't care about other people seeing what I'm doing, right? I don't care about flashing my life and trying to impress people, right? I come on these rooms to chat with you guys for a specific purpose, right? Not to engage in, the flashy, attention-seeking nonsense that social media right now is geared towards, right? That's why everybody's addicted to their phones. It's because these social media platforms are literally engineering the algorithms.
Well, here's the thing. The reason why social media is so damaging is because it portrays an avatar of a person's life that they hope or they wish that they could, display to others. So what you see on their social media, the way that they portray themselves is dishonest, and on here, much different because all is discussing topics and specifically flat Earth for all of us that are here.
Exactly. And I can tell you, like the algorithms that are employed on these platforms are literally tailored to invoke envy, hatred, anger, etc., right? Why? Because these are the most powerful emotions to invoke to get people hooked on something, right? It gets people talking and all this stuff, getting them back on the platform. Why? Specifically, and I can tell you from experience, is the sole purpose is to get people's eyeballs on that screen for the longest period of time, for the explicit purpose of maximizing the probability that they will see ad. Period.
Right. I mean, it's a social. Yeah, it's in sociology basically. I mean, when you have like one. Were you done? I don't know if you were done or not.
Yeah, go ahead. I was saying exactly. Go ahead.
Yeah, so it's also been demonstrated, like, for example, when you have like the biggest boxing or UFC fights, right? It's always the two guys that have been talking the most amount of shit to each other, that have the most amount of controversy behind this and this, and those are the ones that usually sell the most amount of numbers, not the guys being nice to each other. So controversy is like just super common in social media, and that's why so many things go popular in there. And when you have things like TikTok, right? Because I'm always on TikTok, I'm not gonna act like I don't have it, right? You're scrolling and it's addictive because you're scrolling, right? And you're scrolling and you're scrolling and you just find something new every single time, and there's something you might like, and whatever you do like, it's starting to put in your algorithm. So you start scrolling on stuff that you start to like, and it's like it's kind of addicting.
Yeah, yeah. It's all to maximize eyeball time, to maximize the chance of seeing an ad and clicking on it, because that's the only revenue they have, right? Unless, of course,
and in TikTok, TikTok does it the best though. They do it the best because it makes me scroll so much on there. I scroll like maybe 100 times per session, dude. So when you scroll, I think it's about every 3 normal video you get an advertisement. So they get more ads even on there. So I bet they're making even more money because TikTok came up with a beautiful way, and they came up with such a beautiful way of maximizing someone's attention span to the point where now Instagram, just a few months ago, created something like Reels, right? Where it's basically copying TikTok, where you just have a moment where you keep scrolling. So they've done the same exact thing that TikTok has done and added advertisements like TikTok has done. So they're copying their method because it's so useful.
Yeah, a really good example of this is Twitter, or now X, right? Initially, right, there was an argument to be made, but it's no longer the case. Whereby initially, and it's still the case now, I think, Twitter puts a maximum character count on the messages that people can post, right? And the argument initially was, oh, well, in its infancy, it was a smaller company, whatever, they had to save on disk space. If you have millions and millions of people tweeting all the time, that's a lot of characters, it's a lot of storage and database space made, so they had to cap that, right? So as to get the most tweets out, But now, I mean, look, I work in the field, okay? And disk space is not a concern really anymore, especially nowadays with cloud computing and all sorts of distributed systems and shit, okay? But they still, to this day, as far as I know, keep a cap on the number of characters, right? And why is that? There's an argument to be made now, is that they've discovered, and there's studies behind it, I think. I can't source it now, but it's significant, where they know that on average, higher number of characters, right, or words, tend to be used to what do you want to call it? Not invoke, but to express more complicated phrases and claims and stuff like that, which tend to lead to things that are more positive. Or rather, put in the other way, it more often takes higher amounts of words and characters and syllables to express positive, uplifting things than it does negative ones, right? So by arbitrarily putting a cap on it, you're indirectly putting a cap on the ability of people to express themselves. So they tend to say the most short-winded, nonsensical, snippy, snappy, oftentimes provocative things, right? Which in and of itself actually creates a loop of, engagement that tends to be more negative, and then feeds back on itself and increases the chances of people staying on the platform and engaging, and thus actually getting advertisement fed to them, right? So it's a very kind of almost insidious mechanism, all built in on this arbitrary count cap. It's pathetic, in my view.
Yeah, I agree. And especially, Twitter used to be about tweeting things, but now it's really about controversy, because no one's going to give a shit about what you tweet unless it's sort of controversial. And when you scroll on Twitter, if you even have Twitter, I don't know if you do or not, but if you scroll on Twitter ever nowadays, all you're seeing is fight videos. I don't know if it's my algorithms, dude, but I'm literally seeing a bunch of people fighting each other, some dude shooting some other dude. It's like, because Twitter is like kind of uncensored.
Videos. Partially, yeah.
Well, they're interesting. I'm gonna be honest, they're interesting. But I mean, it's like, even on Reddit, right? Reddit, we have a lot of uncensored shit. On Twitter, it's like one of the two apps where you get a lot of uncensored shit. But I keep seeing people fight and shoot and do all sorts of crazy shit. I don't know if that's just my Twitter. Is that just my Twitter, guys?
Does everybody call it Twitter, or do they call it X, or what? What is it?
It's Twitter.
What is going on with that?
Okay. So the X thing is because Elon Musk bought Twitter. I don't know if you knew that, Flatsy, but he bought Twitter, so he changed the name to X.
Well, before he bought Twitter,
my man's still Twitter.
before he bought Twitter, I guess, I remember researching him a bit and how he had aspired to have some sort of social media called X that you could use for like social credit.
Yeah. Licking, thinking shit. Yeah, it's coming.
That was before he bought it, though.
Yeah,
He wants like
It's,
an
I mean,
everything kind of platform, maybe.
It's like, I mean, Elon's weird. He likes, like, I don't know, he likes the sound of X. He has SpaceX and all this other X, and he names his kid like it's math equations and shit. So it's like, I don't know.
Yeah, he's cracked.
With Elon. I mean, at this point, I might as well, name my kid F equals A.
You can't actually claim to know anything about him.
Elon Musk.
Yeah.
At the very least,
I mean, as far as we know, I don't know.
I think he's a certified idiot.
Yeah, they have to build.
Think he's an idiot? I think he's a smart guy.
They have to build out Elon to appear like this eccentric savant type, that does all these weird fucking things. Exactly. And that's just why he's a genius, and we're all dumb fucks.
When in actuality, he's a dumb fuck.
Self-made billionaire, or whatever.
Okay, sure.
He was born in South Africa and had like a pretty decent, well-off family. But I mean, from then on, he built it up to be like a billionaire. But to be honest, I mean, it's sort of inherited wealth from his parents that he got that made it easier.
Yeah, I think that.
As far as we know, Timbo, I don't know. I don't know the certainty of it. I don't know that for facts what happened. But as far as we know,
pretty wealthy.
That he came from a decent, well-off.
His family weren't like billionaires or whatever.
Yeah, they weren't billionaires, but they were well off. That's all it was. But I mean, I'd say that he still kind of built his brand, though. I mean, apart from having a little bit of money.
Anything. You can't say anything.
That was Tesla. Tesla just fucking went crazy.
He purchased Tesla. Never built that ground up.
Yeah, and then got funding from the government.
Oh, that's true too. Yeah.
Yeah, I think his family was in the emerald business or something like that.
He has a lot of government support for his companies, actually.
Yeah, I was going to say that they were emerald mines or something.
Yeah, just your common neighbor profession.
Oh. South Africa.
Certainly not.
I wouldn't say he's. I don't think he's dumb though. I don't think he's dumb. I think he's.
Well, I mean, anytime I've ever listened to Elon speak, I can equate it to like sitting around stoned at 16 and speaking to my mates. It's just all the same fucking shit. Brain in jars and brains in vats and all this crap. Simulations. It's nothing new. It's new to the average person that pays attention to nothing and doesn't really question or think about anything. Possibilities.
Mm-hmm.
That's why it seems fresh. Because the previous genius of the world, Bill Gates, he didn't speak like that. He didn't broach topics.
Why do you call him the previous genius?
Also a bad idiot.
Bill Gates, the previous genius. Why?
Well, he was kind of painted out that way. The tech genius, that gave us Microsoft. Pretty much, commercialized computing for the world.
The real genius is the person who convinced you into the... What is this thing called?
Yeah,
he's muted. Yeah, but I mean, guys like
the real genius is the person that said that you could hold your alcohol.
Yeah, that's it, Tim.
Oh, interesting stuff, man. Mark Zuckerberg as well, the one who created Facebook. And then Mark Zuckerberg got his ass kicked by everyone else after he created Facebook, right? Facebook, you know how Facebook went downhill and everyone was shitting on it, saying only people's mothers or grandmothers are on Facebook now and shit like that, because all the other social medias was catching everyone's attention span was far more interesting than Facebook. So Facebook died off, and no young person's even on it. Like you're never gonna hear a young guy be like, "Yeah, this is my Facebook," or "Can I get your Facebook?" Right? It's like, come on, dude. So that died off.
Is that true? What are they like more? What do they do?
So it's Instagram, Snapchat, basically for socials, and TikTok. You have TikTok if people want to follow you on there. TikTok is where you go to watch stuff, or you might post your videos, right? And then you have Instagram or TikTok where you interact with your friends. I mean, I talk to all my friends on Instagram, basically. None of them ever ask for Facebook, or I never ask for anyone's Facebook, or I never hear it, because Facebook is that outdated, basically. So.
Oh, nice.
All right, Matt.
Yeah, but you're 17, dude.
I posted. Yeah, it's true.
You're right. I'm young, right?
He's not entirely wrong. It's very rare. It's very rare that I ever see anyone young on Facebook, really.
Yeah. But the old people on there, like maybe Timbo. Yes, I am.
I posted you a picture, Matt, of coffee for you.
Yes, thank you.
Bottom up obstruction on a flat surface, baby.
Wait, what is the? Interesting. You know what's funny though? I don't deny that this was obviously the background is similar, but why does the floor like look different? Is it just me?
No,
is it just the angle? It's probably just the angle.
And why?
It's the angle.
Drink decaf.
It's the angle, right?
Notice how the floor becomes extremely reflective the lower angle you get.
I see that. Is this your photo, by the way?
Yeah, probably, I made it myself.
Yourself?
Let me tell you how I did it. So I took the coffee can over to the other side of the room, about 35 feet. And I lowered my camera down towards the ground, and then I took a picture. So the one picture is above the ground, and the other picture is low to the ground. So the one on the top is me standing up, and the one on the other one is me having my phone actually touching the floor. The aperture center is. Let me see if I can get a little more than 3/4 of an inch from the base of the side of the phone. So the aperture is 3/4 of an inch off of the ground.
Get on the phone to Mez, Matt. Get it debunked.
So let's discuss what's really important here. That coffee is not rich and smooth. It can't be.
No, you may say, well, the floor is obstructing it. Now there's a clue in that image. So, Platsy, what is missing from the bottom image?
The metal ring and about a half an inch off the bottom of the can.
The gap in the sideboard.
Okay, so yeah, well.
Okay, you mean like
that? Listen.
Okay, baseboard.
That baseboard.
Sorry, my bad.
The baseboard is a baseboard, and the bottom of the baseboard is a quarter round, which is 3/4 of an inch thick. So the top of the quarter round is 3/4 inch.
So I was right about a half an inch.
So, if you had to guess, because let's just say, for sake of argument, that someone would argue and say, well, the floor is clearly bumpy, right? So if you look at the bottom there, you can see on the left side versus the right that there's only about a thin strip of white. So that would probably be less than 1/8 of an inch, right? So if the whole floor is less than 1/8 of an inch variance, and the camera is 3/4 of an inch above, right? It would clearly see over the 1/8 of an inch variance, right? However, we have disappeared almost 3/4 of an inch.
Also, Matt, are you aware that every surface is some degree of reflective? Even
Yes.
asphalt, everything has a degree of reflectiveness if it's a surface.
Yes, I'm more.
Yeah, Matt, can I ask, is the quality sufficient enough for you?
Yes, the quality is sufficient. You know that's my go-to, obvious. You know I just attack the quality. That's
And
my number one
also,
go-to.
Yeah.
you can't say that he has his aperture below said surface that he's demonstrating this on, because you can't go below the floor.
Right, yeah, you're right. That's sufficient. It's not 1984 quality. That's a rarity. Flat earthers. Flat earthers seem to like shitty quality.
The best way to try to do this effect is at, a long distance and a low angle. The longer the distance and the lower the angle. That's the best way. So, doing it on a table, it's too close. I mean,
Yeah,
for example, I can get
from zooming in. That's
yeah,
where
I can get this effect, before you even get towards the ground. If you get further away.
Mm-hmm. It's a funny profile picture you got there, obvious. Where every time you talk or your mic moves, the sun starts going around the flat Earth. It's because it's probably because you have nitro, but
I control time in day and night.
yes, you do. Just by your sound.
But once I get if I get a new laser, I'll go to this floor and I'll actually benchmark the whole floor for variance. Then I'll be able to tell you exactly what the variance is.
I'm sure you manipulate all the variables.
I mean, going a step above this AI, you could maybe use, the extremely flat machinist bars, having like multiple of them lined up and working along that.
I wanna do this at a bowling alley. The reason is I want to they're very long and they're flat, and but they also have stages. So like you have to step up to get on them. And so you can actually get very far away, lower your camera, right, to a critical angle. Now you are possible of lowering your camera below the angle of the plane, but if you lower the camera continuously, you'll be able to tell when that occurs. And so if you have the right bowling alley and it's far enough away, you could get the effect before you even come close to being at the plane of the floor. You know what I mean? So it'll be clearly obvious. So for example, someone might be sitting in a chair. It's clear that their kneecaps are above the plane of the deck of the bowling alley. And so as you lower it, you'll see that their kneecaps are above and you haven't fell below their kneecaps yet, but you'll still get this effect.
Oh my gosh.
I don't believe any Glober would accept that presentation, really, because a used bowling alley deck, could be warped or damaged. That would be their go-to counter-argument.
Such a good idea,
You'd have
though.
to really verify that it was level.
Or the quality, yeah.
But if you go to a bowling alley, if this is a way that you can prove it to yourself, if you go to the bowling alley and you yourself put your face down near the floor and see if you can see the bottom of the pins at the end of the what is that thing called? The I don't know. Haven't been bowling.
The big long wood thingy. It's its official title.
I was
okay. So listen.
That's not
it's
right.
better. So the proper way to do this test is to find a position where you can transition your view quickly between elevations. Reason is that like the disappearance seems linear. It's not. It's actually kind of like hyperbolic, where it takes off once you get to the close to the critical angle. So you could actually find the sweet spot of the angle where you can start to see the bottom disappear while you're still way above the surface. Okay, do you follow what I'm saying? Like your eye isn't towards the ground. If you get far enough away, you can get the effect with your head not even being all the way to the ground. So intuitively you're above everything. You follow what I'm saying? And then when you experience that thing disappear, you put your body into that zone and you just raise and lower your altitude, like maybe buckling your knees or something. And when you see your head bobbing up and down and you see the bottom blink in and out of existence, while simultaneously knowing and experiencing that you're above the surface, once that happens, your mind is changed forever.
And from then on that, you will have officially...
What do you think, Matt?
I'm tired, man. I mean, I've listened to something about a bowling alley and the floor being flat and putting your head against the floor and you can't see the
bowling pins
balls or something.
The pins.
Bowling pins, yeah, something.
Yeah, they're called lanes. The bowling lanes. I could not think of. I didn't know. I'm not.
I was going to say wrong, but lanes are good too.
Oh.
I took my son to a location where I had him experience this for himself, where he's bouncing up and down way above the surface. And he was able to see the object, not see the object, see the object, not see the object. And the only thing he was doing was altering his altitude above the surface. And so now experientially, going forward, anybody tells him that the bottom of something can't disappear except because of curvature, he's just going to laugh at him.
Good on your boy.
He's been practiced.
Is he your prospect? Is he your prospect for the flat Earth?
What? Oh, children aren't prospects. Children are not prospects. They are progeny.
Yeah.
I mean, you don't get the joke. It's just the joke that we have.
Wisdom, not just flat Earth. Of all things, wisdom.
Is your son a flat earther or a globe earther?
He is a earther.
He's an earther. Well, in school they're teaching him it's a globe. Well, depending if you homeschool around.
Yeah, well, I mean, I've taught him enough things that he could see through when they're talking crap. when they're not talking crap, and if they're validating what they say or if they're just asserting what they say.
Right. Validations and assertions are definitely different things. One is needed to assert the other.
Think about it, from the mainstream's perspective, they think that somebody teaching their child flat earth is odd, and that teaching a regular curriculum is exactly what should be done, right?
Yeah.
But that's like the home team bias,
Yeah. I mean, to be honest, I mean, I think that, whatever you teach your son is whatever you teach your son, and whatever he learns at school as well is also a outside view for him. So I think that it's sort of fair game, and whatever he decides to go to, I mean, if he looks into it enough and he cares enough, his own research, he might end up at his own conclusion.
And maybe your child will end up in one of these servers talking to his child, your child being the globe earth flat earther.
Yeah, that's possible too. I'm young, man. I probably won't have it within like 7 years or something.
And at that time, Scott Mackey will still be in the corner with his notepad writing up his book.
Nuh-uh. It's gonna be nuh-uh.
Whatever. He ain't writing no book, man.
And hopefully Scott Mackey lives a long life, man.
Dude, I'm writing.
Isn't
Listen,
Scott on
I'm
holiday
writing.
right
I'm
now?
writing. I am writing 32 books.
You are?
You'll get
32.
done
Yeah.
before he writes one.
That's great. Yeah, I've also been thinking about, or like, well, I know I'm gonna write a book soon, but I want to write a book.
But see, the problem is I'm writing them intermittently and periodically, squared.
You're just above our levels, man. You're just higher than us, I guess. You're on a higher level. You're in the fourth dimension.
He's an AI. He can multitask.
Yeah.
Yeah, don't forget.
He's half AI and half human. You can see it in the profile picture.
Yeah, don't forget AI. I'm surprised you did, but you're writing them automatically too, right?
Okay.
I'm writing music, but I'm slacking lately. So I don't write books. I write music and guitar licks.
You write lyrics or notation?
Yeah, lyrics and guitar music. So.
Oh, nice. Okay. Do you write in tabs or full notation?
I'll give you a song that I wrote.
Cool.
It's got a bluesy scale down, so it's got a little bluesy lick. A bit bluesy.
Cool. Yeah, it keeps it grounded. That shit, man. I don't compose, but I been studying for.
What? Ed Masto got married while we weren't looking.
Hey.
Good on him, brother. Hey, you want to know something about Ed Masto? I'll tell you. Years ago, he was challenged to go out and try to do a test to where he could get low angle and something far away and see if it would disappear from the bottom. And he went out and did it. Within the week, if I remember correctly.
I wrote that song and that day that I recorded it. So that day I recorded that song, I wrote it. So yeah, the day, yeah. And it was it's much better now because I'm way more used to it. But considering that I wrote it that day, it's all right. It's pretty cool.
Sweet. Gotta check it out.
Yeah, my husband made a pun off of that because I said the day that I wrote that song, he was like, oh, yeah, okay. Yeah, The Day is the name of the song, so that's pretty funny. Punny.
I got a question for you.
Who, me?
Oh, Matt.
He deafened. I think he's listening to my song.
Man, what a stinker. Okay.
Man, Flats, you got pipes, man. Nice, nice setting too. Got the natural reverb in there. Beautiful voice.
Thank you. Thank you. Yeah, that brewery that I worked at, because that's where I used to work. The acoustics there. I could sing somewhere in that place, and you could hear me at the other end, like I was right next to you.
That's cool. I've yet to play in a really significantly reverbish area. I only have my setup that's got artificial reverb, and my acoustics and my spaces are okay there, but nothing like the real world.
I like playing. I like playing live. I'm not big on recording. I hate recording myself, especially, so it's painful. I took the third take of that song when I was recording myself for that contest. I took the third take. I just don't like doing it. It's not my favorite thing to do. And when I recorded in a studio, for the most part, the first take of every song, or like the full take of the song, was good. So I really strive to just get it because I play live all the time, so I can play through a whole song without needing to start over or anything like that, or take clips here and there to have a good recording of the full song. So when I recorded in the studio, the full first takes that I got, I was okay with it. I did not want to go back and redo it and redo it and redo it. No way.
Yeah, it'll save you studio time at the same time, right?
Yeah, I was able to record 5 songs in 4 hours.
Oh,
That was with me playing the song all the way through, and then the guy going back into the back to master it, and then he would play it for us. My husband was with me, and so me playing took no time at all, but him going back there and kind of balancing all the sound out and stuff, that took a while for every song. So
oh
I
yeah.
even before he was done, and he emailed me all of them. So I don't know.
I've already got all of mine.
Yeah, mastery is a hell of an art, man. I knew a couple guys that ran their own studio. They had like all the equipment, like their board was like 100 or 150 inputs wide and all this shit, took like a full whatever 20 by 10 space or something like that with little couches and shit. Very, very fascinating pieces of equipment. And the beauty that comes up when you know your shit, you can stay there all day.
Three millimeters. 69 by 2.4. 69 divided by 2.4.
Yeah, I'd have to finish that. Very well done, Foxy.
Thank you very much. Appreciate that.
You're obviously trained, eh?
I'm obviously what?
Trained. You've got training.
Oh, well, self-taught for the most part. I went to college for music.
Oh, you too, eh?
Yeah, and I
That's
played
cool.
alto. I played alto saxophone and jazz band.
Oh yeah, you too. Oh my god, that's funny.
Yeah, and I did private lessons with alto saxophone and voice, and I tried to do like a private classical guitar. I did piano also. I took a piano class, but it wasn't private. It was like a class. So we had like exams on like the
Yeah,
pieces.
just for the theory at least.
Yeah. Yeah, I tried to take guitar, but I wasn't able to really do that. But I just bought Galvador Ibanez classical, and I learned how to string it, with the nylon strings and tying them and at the ends. I learned how to, restring. I still have that guitar.
That's cool.
A bunch of others too, but anyways, that was my first one, and I was not my first guitar ever. Actually, my sister bought me my first guitar ever, and I gave it back to her son when he was old enough to start picking up guitar, and now he knows how to play. So it's like one of those things that we're passing down in the family. So that's pretty cool.
Oh yeah, family thing, eh? It tends
Yeah.
to be like that. In my experience, I knew a couple people, their parents played something or whatnot, and the kids pick it up and all that shit,
Well,
Grandkid.
but I did, and I guess I made an impression on them because of playing guitar and singing for the kids always. I still do. If I'm ever around a bunch of them, I'll get out my guitar and play some songs for them, and to hopefully inspire them to be creative and do stuff like that.
Yeah,
And,
yeah.
and
If not just to indulge in some color of some sort, right?
yeah, but when I was getting classically trained in guitar, well, I wasn't actually classically trained. I was self-taught. My professor couldn't actually do a private lesson for me, but every now and then I would ask him if he could show me some things if I'd bring my guitar to class, and he had some time after. He would go over some things, and he gave me sheet music to learn on classical guitar. So I learned a few things like I had to learn green sleeves because I knew how to play it on saxophone and piano, and I wanted to learn how to play it on guitar so I could play. But study in A minor, and there was a few others that I can't remember. I don't have the sheet music for him anymore because I had to give it back to him. But other than that, yeah, I was able to teach myself a bunch of stuff on classical guitar, and then I went back to. I learned how to play with a pick like within the last 5 years. So I've always been a finger picker. So now I'm not a finger picker. I am still, but now I know how to play really well with a pick.
Yeah, they're very different. Very different. Good for you, man. I learned a little bit of guitar and bass when I was a kid there, but I let it go. Kind of stuck on classical piano for the last decade or so. But I was into percussion for a long time. Went down the jazz and prog and metal fields for a while. But once I moved out, was on my own shit. Can't really shred anymore. My knees are all fucked up now, actually, because I played too much. So, put that to the side, and now it's all classical piano. Can't let it go.
I taught my son a bit of percussion, and he took off with it. He really liked it, and that taught him kind of syncopation and timing. So that was really good in that early on.
Yeah. I remember when I was studying jazz percussion, they forced us to take a piano class at the same time, and vice versa. Right? So if you're doing jazz piano or classical piano, they would force you guys to take a percussion class because they cross over, and just for timing and coordination and stuff. Yeah, it's very important. It's the base of it all. So keep at it. Good for you.
Yeah, when my son was 2, he could play full nursery rhymes with one hand, like single note on piano, because I taught him that.
Good stuff. Good stuff. Yeah, keep at it.
I just like teaching him stuff, man. He's so smart. He can, well, I don't know. I think that all the children kind of have that kind of capacity. Just it takes a parent like willing to show them early on and see if they can figure it out. That's what he did. I watched him figure out how to play Twinkle Twinkle Little Star in front of my face, and it was so fantastic. I was so proud. I mean, I don't think proud's the right word. I was very happy, joyful. Yeah, it was Twinkle Twinkle Little Star. My husband tried to say it was ABCs, which is the same thing, same tune.
Oh yeah, it's the same.
It's the same tune.
Good stuff. Anyway, I'm gonna duck out. It's getting very late for me. Nice chat with you all. God bless.
Yeah, God bless. You have a good one. I'm probably about to also. You all have a good one. God bless.
I would love a popsicle. Oh,
You guys are all cowards.
Oh, this shit is not. What the fuck? Wow, everybody just mudding in here. You all just not doing shit. The fuck you doing? What the
Sign on. So who's the gravity racist in here? Anyone? No one? So the Earth is round. Okay. No response in 3, 2, 1. I win. I win the argument. I won this debate. This room is mine. Yeah.